Imagine looking up at a sky full of stars and knowing that most of what you see is already gone. Lost. Not just hidden or too dim, but truly gone. Slipped away from us, forever, carried on a cosmic current that's moving faster than the speed of light. Welcome to the Science for Deep Sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. This isn't science fiction. It's the quiet, startling reality of our universe. We live in a cosmos that is not just expanding, but is accelerating its expansion, pulling entire galaxies away from us on a river of stretching spacetime. It's a subtle truth, one that doesn't make a lot of headlines, but it completely changes our place in the cosmos. It means we are living on a shrinking island in a vast, dark ocean. The lights from distant shores aren't just far away, they're sailing away so fast we can never, ever reach them. We can see their ghostly old light, a snapshot from the past, but we can never get a message from their present. We can never visit. For all practical purposes, they're already gone. Tonight, we're going to explore this idea of a lost universe. We'll journey to the very edge of possibility, a boundary in space and time called the cosmic event horizon. We'll find out how a mysterious force called dark energy is stealing galaxies from our future. And we will confront a staggering number, that 94% of all the galaxies we can, in principle, even detect, are already beyond our reach. This is the story of the lost universe, of the quiet fading of nearly 2 trillion galaxies, and what it means to be alive in this special, fleeting moment when we can still see it all. Let's picture the universe as a vast, dark ocean. Our galaxy, the Milky Way, is our small, familiar island. And across this ocean are other islands, trillions of them, other galaxies just as complex and brilliant as our own. For all of human history, we've looked out from our shore, dreaming of building a ship that could one day visit them. But there's a catch. The ocean itself, the very fabric of space, is stretching. And it's stretching faster and faster every second. An invisible current is pulling everything apart. Now, imagine our fastest ship can only travel at one speed, the speed of light. That's the ultimate cosmic speed limit. But what happens when the current of spacetime itself is flowing away from us faster than our fastest ship can possibly sail? That's the story of how 94% of the galaxies we can see have already slipped over our cosmic horizon. They're like ships whose lights still reach us across the waves, beautiful echoes of what they once were. But their real locations, right now, are so far away and moving so fast that we can never catch up. They were lost before we ever had a chance to say hello. The discovery of a runaway universe. To understand how we can lose the universe, we first have to understand how we found out it was running away from us. For most of history, we saw the universe as a fixed, eternal stage. It took Albert Einstein, in the early 20th century, to give us the math that would tear down that ancient idea. His theory of general relativity, published in 1915, described gravity as a curve in spacetime. But when Einstein applied his equations to the whole universe, he found something deeply unsettling. They predicted the universe had to be either expanding or contracting. It simply refused to stand still. This idea was so bizarre that even Einstein couldn't stomach it. He famously stuck a fudge factor in his equations, the cosmological constant, to force the universe to be static. He later called it the biggest blunder of his life. The proof of an expanding universe came not from a theorist, but from an observer. In the 1920s, an astronomer named Edwin Hubble, working at the Mount Wilson Observatory, made a series of game-changing discoveries. Using the world's most powerful telescope, he proved that the faint, blurry smudges in the sky weren't clouds in our own galaxy. They were island universes, entire galaxies, millions of light years away. But that was just his opening act. Hubble then measured the light from these galaxies and noticed something strange. The light was stretched, shifted toward the red end of the spectrum. This is called redshift, and it's a cosmic Doppler effect. Just like an ambulance siren's pitch drops as it speeds away, the wavelength of light from a receding object stretches and gets redder. Hubble found a clear pattern. The farther away a galaxy was, the faster it was moving away from us. This was the bombshell. The universe wasn't static at all, it was expanding. Now, don't think of this as a big explosion with galaxies flying through space like shrapnel. A better picture is raisins in a loaf of baking bread. As the dough expands, every raisin moves away from every other raisin without actually moving through the dough. The space between them is what's expanding. That's our universe. Space itself is stretching, carrying galaxies along for the ride. For decades, the big question was, what happens next? Would gravity eventually slow the expansion and pull everything back together in a big crunch? Or would it expand forever? The answer, which came in the late 1990s, was more shocking than anyone imagined. Two separate teams of astronomers were using a special kind of exploding star, a Type Ia supernova, as a cosmic measuring tape. These supernovae always explode with the same intrinsic brightness, so they're perfect, standard candles. You can tell how far away they are just by seeing how dim they appear. Both teams found the same unbelievable result. The most distant supernovae were dimmer, and therefore farther away, than they should have been if the expansion was slowing down. There was only one possible explanation: the expansion of the universe isn't slowing at all. For the last 5 billion years, it's been speeding up. The universe is in the grip of an accelerating expansion. This discovery was so profound it earned the team leaders the Nobel Prize in 2011. It meant some strange, repulsive force was pushing the cosmos apart. They gave it a name: dark energy. Dark energy and the cosmic speed limit. The discovery of dark energy solved one mystery but created an even bigger one. What is this stuff? The honest answer is, we have no idea. It is the single biggest mystery in all of physics. But we do know what it does. According to our best model of the universe, everything we can see, stars, planets, you, me, makes up less than 5% of the cosmos. About 27% is dark matter, another mystery substance that provides the gravitational scaffolding for galaxies. And the rest, a whopping 68%, is dark energy. Unlike matter, which clumps together with gravity, dark energy seems to be a property of space itself. It has a constant energy density. So as space expands, more dark energy pops into existence to fill it. Think of it like an anti-gravity force built into the fabric of reality. As the universe got bigger, matter and dark matter thinned out, and their gravitational pull got weaker over cosmic distances. Dark energy, however, stayed just as strong and eventually became the dominant force. About 5 billion years ago, its repulsive push overtook gravity's pull, and the acceleration began. This accelerating expansion leads to a truly mind-bending consequence. Remember Hubble's rule: the farther the galaxy, the faster it recedes. That's not because it has a bigger engine, it's because there's more expanding space between us and it. A galaxy twice as far away has twice as much expanding space, so it recedes twice as fast. So you might be asking a perfectly logical question: if you go far enough out, won't you eventually find a galaxy that's receding faster than the speed of light? And the answer, amazingly, is yes. But wait, doesn't that violate Einstein's whole "nothing can travel faster than light" rule? Nope. Relativity says nothing can travel through space faster than light. But the expansion of the universe isn't an object moving through space. It is the stretching of spacetime itself. There is no law that says space can't expand as fast as it wants. This creates a critical boundary, a moving target known as the Hubble sphere. Right now, it's at a distance of roughly 14.4 billion light-years. Any galaxy beyond that point is, as of today, receding from us faster than the speed of light. But that's not even the real point of no return. To understand what is truly, irrevocably lost, we need to talk about an even more profound boundary, the cosmic event horizon. The horizon of no return. The word horizon makes us think of the line where the sea meets the sky. You can see ships on this side of it, but beyond that line, they're hidden by the Earth's curve. But if you sail toward the horizon, you can always reach where it was. The universe's horizons are far stranger and more absolute. And this is where we need to be really clear, because there are two different kinds that matter for our story. First, there's the asterisk particle horizon. This is the edge of the asterisk observable universe. The universe is 13.8 billion years old, so light from the most distant objects has been traveling for 13.8 billion years to reach us. But in that time, the point where that light began its journey has been carried even farther away by cosmic expansion. Today, that point is about 46.5 billion light-years from us. So, the observable universe is a sphere about 93 billion light-years across. Every galaxy we've ever seen lies inside this bubble. It's the boundary of our past. But there is another horizon, one that dictates our future. It's called the asterisk cosmic event horizon. This is the true point of no return. It marks the farthest distance from which light emitted today could ever reach us, even if it had an infinite amount of time to get here. Think back to our lighthouse analogy. Seeing a distant galaxy is like seeing the light from a lighthouse that was switched on billions of years ago. The event horizon asks a different question. If the keeper switches on a new light right now, will we ever see its beam? Because of dark energy, for most galaxies, the answer is no. The cosmic event horizon is currently a boundary around 18 billion light-years away. Any galaxy inside this 18 billion light-year bubble is still reachable, at least in principle. If we sent out a message at the speed of light today, it would be fighting against the current of expanding space, but because the galaxy is close enough, that message would eventually arrive. But for any galaxy that is currently beyond that 18 billion light-year line, the game is over. Forever. The space between us and them is expanding so fast that it's like trying to swim up a waterfall that's flowing faster than you can move. Even a beam of light, the fastest thing there is, gets carried backward by the current of spacetime. It will never, ever reach us. This is the ultimate horizon. An object that crosses a black hole's event horizon is lost to the outside universe. In the same way, a galaxy that crosses our cosmic event horizon is lost to us. And this isn't some far future prediction. It's happening as we speak. The 94%. So what does this all mean when you put it together? We live in an observable universe that is 93 billion light-years across, and the latest estimates suggest it's filled with maybe 2 trillion galaxies. 2 trillion islands of stars. And yet, the vast majority of them are ghosts. When we look at a galaxy that's 20 billion light-years away, we're seeing its ancient light. That's a picture of the galaxy as it was in the distant past. But its current location, where that galaxy is right now, is far beyond our 18 billion light-year event horizon. It's receding from us faster than light. Any signal it sends out today will never reach us. It has crossed the point of no return. We're looking at a postcard from a ship that has already sailed over the edge of the world. When cosmologists do the math, the conclusion is breathtaking. Of all the galaxies within our observable universe, the 2 trillion galaxies whose ancient light we can theoretically see, a staggering 94% of them are already permanently beyond our reach. Let that sink in. For every 100 galaxies we can see, only 6 are still part of our accessible universe. The other 94 are already cosmically lost to us. We are cosmic archaeologists, studying the faint, redshifted light of ruins we can never touch. The numbers are hard to wrap your head around. Every single year, the expansion of space pushes about 160 billion stars worth of matter over that horizon. It's a quiet, invisible exodus. No fanfare, no announcement. Just a silent, steady loss. We can see them, we can study their past, but we can never go there. We can never know what they're like today. They are part of our observable universe, but they are not part of our accessible universe. The inventory of places we could ever explore has already been slashed by 94%, and the number keeps growing. We've journeyed to the edge of what's possible and looked into the abyss of what's been lost. It's a trip that reveals not just the incredible scale of the cosmos, but also the profound questions it makes us ask. If you love wrestling with these huge ideas, and you enjoy exploring where science meets philosophy, consider subscribing. We dive into mysteries like this every week, and by joining us, you won't miss what's next. Your support is what allows us to keep asking these big questions. Our lonely future. The accelerating expansion of the universe isn't just a fact, it's a prophecy. It foretells a future that is profoundly different from the one we know. A future of growing isolation and, eventually, ultimate loneliness. Let's fast forward. As space keeps expanding faster and faster, the galaxies just beyond our reach will recede even more quickly. Their light will get more and more redshifted, stretching until it becomes undetectable. One by one, the galaxies will simply wink out of our sky. On a human timescale, this is incredibly slow. But on a cosmic one, it's inevitable. In about 100 billion years, every galaxy outside of our own local group will have vanished beyond our event horizon. The night sky, even for the most powerful telescopes, will be almost completely black. Our local group is our immediate cosmic neighborhood, a small cluster of about 80 galaxies all bound together by gravity. The main players are our Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. Gravity is strong enough here to win the fight against cosmic expansion. While the rest of the universe flies apart, our local group holds together. In fact, Andromeda is actually heading right for us. In about 4-5 billion years, our two majestic spiral galaxies will start to merge in a cosmic dance that will last for hundreds of millions of years. The result will be one single, giant elliptical galaxy, which some astronomers have already nicknamed Milkomeda. So, the far future of our cosmic island looks like this: one massive galaxy, alone. Beyond it? Nothing. Just an endless, featureless void. All the other trillions of galaxies will have been carried away by the tide of dark energy, their light so stretched that, from our perspective, they've been erased from existence. Future astronomers living in that giant, isolated galaxy would have no way of knowing that other galaxies ever existed. They would have no Hubble deep field to inspire them. They would look out and see only their own island of stars, surrounded by eternal, empty darkness.
They would find no evidence of the Big Bang and no sign of cosmic expansion, because there would be nothing left to measure. They might even develop a theory like general relativity, and their equations might tell them the universe should be expanding. But with no way to prove it, they might dismiss the idea as a mathematical error just like Einstein once did. They would logically conclude that they lived in a single, static universe, completely alone. The glorious, galaxy-filled cosmos we know today is a fleeting spectacle. The knowledge we have of the Big Bang, of expansion, of the 2 trillion other galaxies is only available because we happen to be living in a very special era. We started with our galaxy as an island in a vast ocean. We've learned that this ocean's currents are pulling all the islands apart, driven by the mystery of dark energy. We journeyed to the cosmic event horizon, a boundary beyond which 94% of the galaxies we can see are already lost forever. So what does it mean to live in a universe like this? On the one hand, it's a story of incredible loss. The universe is richer than we ever imagined, yet almost all of it is off limits. We're like kids with our noses pressed against the window of a shop that will never open. We can look, but we can't touch. The story of those lost worlds will play out without us. But there's another way to see it. The fact that we know any of this is a miracle. We are a species on one tiny planet, around one ordinary star, in one of trillions of galaxies. And yet, with reason and curiosity, we have pieced together the story of the cosmos. We have measured the echo of creation. We have charted the expansion of space. We have glimpsed the force that will decide the fate of reality itself. This knowledge makes our moment in time incredibly precious. We are living in the twilight of the grand cosmic spectacle. We are here, now, while the sky is still full of light, a library of cosmic history that lets us read the story of our own origins. Future astronomers will inherit a sky that has been wiped clean of its history, a sky that tells no tales. This realization doesn't have to be sad. It can be a call to wonder. It's a reminder of what a privilege it is to exist right now. It tells us that the view from our island is temporary and priceless. It urges us to look up, to learn, and to appreciate the magnificent, fleeting, and achingly beautiful universe we are so lucky to witness before it all fades to black. Part 2. What beyond reach really means. When we hear the phrase beyond reach, we usually imagine something frustrating, but temporary. A mountain is beyond reach until we climb it. An island is beyond reach until we build a boat. A distant planet is beyond reach until we invent a better engine, or wait long enough, or become patient enough to cross the dark distance between worlds. In ordinary life, far away does not mean forever impossible. It just means the journey is long. And that is exactly why the true meaning of this cosmic phrase can be hard to feel at first. Because when astronomers say that a region of the universe is already beyond our reach, they are not saying it is too expensive to visit, or too remote for our current technology, or too inconvenient for a future civilization with better ships and better ideas. They mean something much quieter, and much more final than that. They mean there are places in the universe that no signal, no probe, no spacecraft, and no traveler could ever get to, not because we are weak, but because the structure of reality itself has turned those places into permanent exiles. They are not just far. They are gone from the future. That is the difference this part is really about. The difference between something being difficult to reach, and something being unreachable in principle. If you want, you can picture it in the simplest possible way. Imagine standing on a long shoreline at dusk. Far out at sea, there are ships. Some are close enough that, with enough time, a small boat could still reach them. Some are already so far out, and the tide is pulling so strongly, that even the fastest possible boat could row forever and never close the gap. The farther ship is not merely farther away. It belongs to a different category altogether. It has slipped into a kind of permanent separation. That is much closer to what the universe is doing. The reason this feels so strange is that our instincts were trained on a small world. A human world. A world of roads, oceans, and mountains. On Earth, distance is usually static. Paris does not keep sliding away from Jakarta while you are on the airplane. The house at the end of the street does not drift farther down the road while you walk toward it. The target stays where it is, and the only real question is whether you can cover the distance. But the large-scale universe does not behave like a roadmap. Its distances are not fixed. They are living distances. Stretching distances. Distances that keep changing while anything inside the universe tries to cross them. And once that idea settles in, the whole meaning of reach begins to change. In everyday life, movement seems simple. If you walk at 5 kilometers per hour toward something standing still, you get closer. If you run faster, you get closer more quickly. The target is there. The space between you and it is just empty stage. A passive background. Cosmology asks us to drop that picture. On the largest scales, space is not just a stage. It is part of the story. It expands. It stretches. It changes the geometry between one place and another. So when a distant galaxy lies out there in the dark, the question is not merely how fast you can travel. The question is what the space between you and that galaxy is doing while you try. And the answer, on cosmic scales, is that the space between you and that galaxy may be growing the entire time. Not because the galaxy is firing its engines and fleeing in panic. Not because the universe exploded long ago and everything is still coasting outward through an empty void. But because spacetime itself is stretching, carrying large islands of matter farther apart. This is the part that is easy to say and hard to feel. Galaxies are not usually racing through space away from us like bullets through the air. Rather, the fabric between galaxies is expanding. If you like, think again of the raisin bread image from the first part. The raisins are not crawling through the dough. The dough itself is swelling, and every raisin finds every other raisin farther away than before. Or imagine a pattern drawn onto a rubber sheet. Two dots can remain still relative to the sheet, and yet the distance between them can increase if the sheet is stretched. No dot has to actively move across the surface for separation to grow. That is much closer to the cosmic picture. And once space itself is allowed to change, distance stops being a simple obstacle. It becomes a moving target. Now the old question, can we get there? Must be replaced by a stranger one. Can we get there faster than the universe can pull it away? That is the real question hidden inside the phrase beyond reach. It helps to make this more concrete. Suppose you could leave the Milky Way in a perfect ship. No breakdowns. No fuel problems. No aging. No life support limits. Suppose the ship could travel at the absolute fastest speed anything in the universe can travel, the speed of light. Even then, there would still be distant regions whose separation from us grows so stubbornly, and eventually so effectively, that even light itself could never close the gap from this moment onward. That is the point where, far away, becomes lost. Not because the trip would take billions of years. Not because the passengers would run out of food. Not because humanity lacks the courage or intelligence. But because even nature's own speed limit is no longer enough to overcome what expanding space is doing. And this is where many people instinctively push back. It feels impossible. Surely, if you just wait long enough, light will get there eventually. After all, light is unimaginably fast. It crosses Earth more than 7 times in 1 second. It travels from the moon to us in just over a second. From the sun, in about 8 minutes. Even across the enormous span of our solar system, light feels almost magical in its speed. So how can even light fail? The answer is not that light slows down. It does not. The answer is that the arena through which it travels can change while it is in transit. Imagine walking on a moving walkway at an airport. If the walkway moves backward more slowly than you walk forward, you still make progress. Slowly perhaps, but progress. If the walkway moves backward at exactly the same speed you walk forward, you stay in place. And if it moves backward faster than you can walk, then despite all your effort, despite each step, despite the feeling of motion, you're carried away from your destination. Cosmic expansion is not exactly like that, but it gives the right kind of intuition. There are regions of the universe for which the expanding separation acts like a retreating walkway. If a light signal starts too late, from too far away, then even as it travels properly through local space, the overall gulf between source and destination can continue growing in such a way that the signal never arrives. This is one of the strangest ideas in all of science, because it forces us to separate two things that usually feel identical. We must separate motion from success. A beam of light can be moving exactly as physics demands, and still fail to ever make contact. A destination can exist, can even be visible in some ancient sense, and still be unreachable from now on. That last part matters a great deal. When we say a region is already lost beyond reach, we are talking about the future relationship between us and that region. We are not saying it never existed. We are not saying no light from it ever reached us. In fact, much of the poignancy of this whole subject comes from the opposite. We may still receive old light from places whose present reality is already forever cut off from us. We can be illuminated by their past, while being denied their future. That is not a poetic exaggeration. It is one of the defining features of the expanding universe. And it means the cosmos is not just vast. It is temporally divided, separated not only by distance, but by what can still be exchanged from this moment onward. In ordinary life, reach is mostly about strength and patience. If a village is far, you travel longer. If a mountain is high, you climb harder. If the ocean is wide, you build a stronger vessel. In cosmology, reach is about causal possibility. Can something done here and now ever influence something there and then? Can a message sent today arrive there someday? Can a traveler beginning now ever enter that region? If the answer is no, then the region is not merely remote. It has left our future. And this is why cosmologists sometimes talk about an accessible universe and not just an observable one. There is a difference between the universe we can, in some sense, see, and the universe we could ever meaningfully interact with. The first is larger. The second is smaller. Much smaller. The heartbreaking part is that our eyes and our instruments do not immediately reveal this difference. The night sky does not come labeled. No galaxy carries a small sign saying, visible, but unreachable. To the eye, a galaxy that could still, in principle, exchange signals with us may look no different from one already lost beyond any future contact. And because of that, the universe allows us to keep a certain illusion for a while. It lets us look outward and imagine everything luminous as part of one great connected whole. But the connection is thinner than it looks. The cosmic ocean is not one open sea. It is an archipelago being pulled apart. The more carefully we study expansion, the more we realize that visibility is not the same as access, and distance is not the same as destiny. Let's slow down even more and make the distinction cleaner. There are, broadly speaking, three kinds of far. The first kind is ordinary far. Something is distant, but fully reachable. It may take a great effort, a very long time, and technology far beyond ours, but physics does not forbid the meeting. The door is still open. The second kind is practical far. Something might be reachable in principle, but never by beings like us. Maybe the travel time would be too long. Maybe the energy required would be absurd. Maybe civilizations would die before making the trip. In this case, the limit is real, but it is a limit of circumstances. The third kind is cosmological far. This is the deepest kind. This is where the door is not merely heavy, but sealed by the geometry of the universe itself. No future ingenuity changes that. No engine solves it. No patience overcomes it. The destination has crossed from hard to impossible. That third category is what we mean here. Already lost beyond reach. If you really sit with that, it changes the emotional tone of the universe. Because it tells us that cosmic loss is not only a future event. It is not something waiting trillions of years ahead. It is already built into the sky. The separation is underway. The archive is shrinking. The set of places that could ever become part of our future conversation is smaller than the set of places whose old light still happens to wash over us. So the true scale of the lost region is not just about miles or light years. It is about futures that can no longer happen. There are conversations that can never occur. Journeys that can never begin in any meaningful sense. Civilizations that may exist, or may once have existed, whose present state will remain forever inaccessible to us, not because of ignorance, but because the universe has quietly closed the channel. That is what makes this different from ordinary distance. Ordinary distance is hopeful. It whispers, not yet. Cosmological loss says, never again. And yet, because the universe is gentle in how it reveals its brutal truths, This never again does not arrive with drama. Galaxies do not vanish in fireworks. The sky does not tear. There is no cosmic alarm bell. The process is patient, silent, almost polite. Old light continues arriving long after the deeper separation has already happened. The universe lets us keep seeing the glow, long after the possibility of contact has faded. There is something hauntingly beautiful about that. It is as if reality itself is giving us one last look, one last delayed shimmer, one last postcard from places that no longer belong to our future. And this is why the phrase "already lost beyond reach" carries such unusual weight. It is not really about travel. It is about relationship. About whether two regions of the universe still belong to one another in a meaningful causal way. If they do, then however difficult the journey might be, there remains some thread, however thin, connecting the two. If they do not, then we are looking at a kind of cosmic estrangement. A final drifting apart written into spacetime itself. The more human way to say it might be this. The universe is not just expanding in size. It is expanding in separation. Not only miles, not only darkness, but separation of futures. And we happen to live in a very special era, one in which the sky still preserves a record of much more than we can ever hope to touch. We are late enough to know the expansion is happening, but early enough to still witness the traces of what is being lost. That gives our moment in cosmic history a strange quality. It is both privileged and melancholic. We live in an age of visible abundance and invisible exclusion. An age when the universe still looks more connected than it truly is. And perhaps that is why this idea settles so deeply once it is understood. Because it reaches beyond astronomy and into something almost existential. It reminds us that not every horizon is a promise. Some horizons are boundaries in a stronger sense. Some are not there to be crossed, but to reveal the shape of what can no longer be shared. Still, it is worth ending this part on one more subtle thought. Unreachable does not mean unreal. Those regions are not less real because we cannot go there. They are not erased because we are excluded from them. The lost universe is still universe. Still full of matter, history, structure, and perhaps unimaginable complexity. It continues without us. It simply no longer belongs to the circle of places our future can ever touch. And that may be the deepest shift of all. To understand that the cosmos is larger than access, larger than observation, larger than participation. There are parts of reality that remain real while being forever removed from us. If these slow journeys through the universe help you rest a little deeper, you can quietly subscribe, leave a like, or share where in the world you're listening from tonight. I always like imagining these ideas drifting through so many different rooms in the dark. Because in the next part, the story becomes even stranger. We are going to look at a distinction that feels impossible the first time you hear it, but sits at the very center of modern cosmology. How can we still see places that are already beyond reach? How can ancient light arrive from realms whose present state can never contact us again? And once you understand that split between seeing and reaching, the night sky begins to feel different. Not emptier, but more fragile, more like memory. Part 3. The difference between seeing and reaching. There is something deeply misleading about light. Not because it lies, exactly, but because it arrives late. And when it arrives, it carries a version of reality that may already be gone. If you sit quietly with that thought for a moment, the whole sky begins to feel a little different. Softer, stranger, and far less immediate than it looks. The stars above you seem present. Galaxies in telescope images seem like places that are simply far away, waiting patiently in the dark. They appear to belong to the same shared moment as you do. As if the universe were one giant room and everything in it were merely arranged at different distances from your chair. But that is not how the cosmos really works. The universe does not let us see things as they are right now. It lets us see them as they were when their light began its journey. And sometimes, that difference is small enough to ignore. Sometimes it is only a few seconds, or a few minutes, or a few years. But on the largest scales, the difference becomes so extreme that what we see and what we could ever reach stop belonging to the same category entirely. That is the quiet distinction we are stepping into now. Seeing is not the same as touching. Seeing is not the same as traveling. Seeing is not the same as still having access. And once you understand that difference, the visible universe starts to feel less like a map of reachable destinations, and more like a museum of delayed light. It helps to begin close to home, where the idea is easier to feel. When you look at the sun, you are not seeing it in the exact present moment. Sunlight takes about 8 minutes to cross the distance to Earth. So the bright disk hanging over the horizon, warm and ordinary, is actually the sun as it was 8 minutes ago. If, in some impossible scenario, the sun were to vanish this instant, we would not know right away. Earth would continue receiving its light for those last 8 minutes. For a brief time, we would still see something that no longer existed in the form we were seeing. The same is true for the moon, though on a smaller scale. We see the moon roughly 1¼ seconds in the past. Jupiter appears to us as it was tens of minutes ago. Neptune, several hours ago. Distance always means delay, because light, though incredibly fast, still takes time. This is easy enough to accept inside the solar system, because the delays feel manageable. They still fit comfortably inside a human imagination. 8 minutes is a commute. A few hours is an afternoon. Even if the information is delayed, we still feel like the object and our knowledge of it are part of the same living relationship. But then the scale widens. The nearest star beyond the Sun, Proxima Centauri, is about 4.24 light-years away. That means when you look at it, you see light that began traveling toward us more than 4 years ago. Sirius, one of the brightest stars in our sky, appears as it was around 8.5 years ago. Betelgeuse, the red supergiant so many people like to talk about when supernovas come up, is seen hundreds of years in the past. And already, even before we leave our own galaxy, a quiet emotional shift begins. You are not looking at a star in the same moment as yourself. You are looking at a message, a delayed one. A fragment sent across darkness. Now expand the scale again, and the difference becomes profound. The Milky Way is about 100,000 light-years across. So even within our own galaxy, light from one side can take tens of thousands of years to reach another. When we begin looking at other galaxies, the delays become immense. The Andromeda Galaxy, our nearest large galactic neighbor, is about 2.5 million light-years away. So the beautiful spiral shape astronomers photograph is not Andromeda as it is now, in any ordinary sense. It is Andromeda as it was when early humans were just beginning to use simple stone tools on Earth. And beyond Andromeda are galaxies tens of millions, hundreds of millions, even billions of light-years away. Some of the light we detect with great telescopes began traveling long before Earth had forests, long before dinosaurs, long before our planet itself was fully formed. We look outward, and in a very literal way, we look backward. This is why astronomers sometimes say that telescopes are time machines. Not magical ones. Not in the science fiction sense. But real instruments of temporal delay. The farther out we look, the older the light becomes. A distant galaxy is not showing us its current face. It is showing us an archival image, a preserved chapter from long ago. And this is where the sky becomes deceptive. Because the human eye, and even the human imagination, tends to mistake visibility for present reality. If we can see a galaxy, it feels like that galaxy is there for us in some meaningful present tense way. It feels available. It feels like part of the same cosmic moment. But what we actually possess is not its present. We possess the light that left it in the past. And that may be all we ever get. Try thinking of it this way. Imagine receiving a letter from someone on a ship far out at sea. The letter tells you where they were, what the weather looked like, how the water moved around them, and what they thought the future might bring. The letter arrives years later. You can hold it, read it, study the handwriting. You can know that the ship was once there, in that place, under that sky. But the letter does not tell you where the ship is now. And it does not mean you can still reach it. That is the difference between seeing and reaching in the universe. Light is the letter. A galaxy's visible image is the letter. Sometimes a beautiful one, sometimes a very ancient one. But the existence of the letter does not guarantee an open route to the sender. In fact, in an accelerating universe, the opposite can be true. You may still be receiving old light from a place whose present state has already slipped permanently beyond contact. That is the key idea. We are not just looking at distant things. We are often looking at old emissions from places whose current reality is already inaccessible. And this is one of the hardest truths in cosmology for the mind to settle into, because it splits a single intuitive picture into two separate realities. There is the reality we can see, and there is the reality we can still reach. Those are not the same universe. The first is larger, much larger. The second is smaller, tighter, and more fragile than it appears. This is why the night sky can feel full and empty at the same time, though not in any obvious way. It is full of information, full of structure, full of ancient light. But some of what it offers us is already only historical. Like looking through the windows of a train station and seeing the fading red lights of a train that has already passed the point where tracks still connect to you. The light reaches you. The destination does not. To really feel the distinction, it helps to compare two kinds of objects. First, consider Andromeda. It is far away, yes, but it is part of our local group, a small cluster of galaxies gravitationally bound together. In fact, Andromeda is moving toward the Milky Way, not away from it. Over billions of years, our galaxies are expected to merge. So Andromeda is not only visible, it is, in a deep cosmic sense, still part of our shared future. Its light comes to us from the past, yes, but the galaxy itself has not been carried beyond all future contact. It remains within the same gravitational island. Now compare that with a much more distant galaxy, one carried outward by the expansion of space and then driven farther and farther away by the accelerating effect we call dark energy. We may still receive ancient light that left it billions of years ago. Our telescopes may resolve its shape. We may give it a catalog number. We may analyze the chemistry of its stars, estimate the mass of its halo, infer the rate at which it formed new suns. In that sense, we know something about it. But knowledge is not access. Its present light may never reach us. A message sent from it now may never arrive. A traveler leaving here now, even at light speed, may never reach where it is becoming. So the galaxy is visible and unreachable at once. Seen, but not shared. Known in outline, but absent from our future. This distinction matters because it changes what observation actually means. In daily life, seeing something often implies a line of possible action. If you can see a house on a hill, you can probably walk there. If you can see a boat near shore, perhaps you can sail out to it. Vision, on human scales, is usually an invitation to movement. The eye and the body belong to the same practical world. The universe breaks that connection. It allows the eye to wander into regions the body, or any future messenger, cannot follow. So telescopes do something almost paradoxical. They expand our awareness without equally expanding our reach. They make the universe feel larger in knowledge, while reminding us how small the accessible portion truly is. In a way, astronomy is full of this bittersweet trade. The better our instruments become, the more ancient light we can collect. We discover more galaxies, more early structures, more hints about what the young universe was doing. We deepen our understanding. But greater visibility does not reopen closed futures. It does not reverse expansion. It does not restore access. We can improve the sharpness of the postcard. We cannot step into it. And maybe that is one reason deep cosmology has such a peculiar emotional tone. It is not just science in the sense of measurement and theory. It is also a confrontation with limits that are not practical, but built into the architecture of reality. The visible universe is not a menu of destinations. It is partly a historical record, partly a field of ongoing relationships, and partly a glow from places already gone from our future. The more carefully you hold that idea, the more the sky begins to resemble memory. Not false memory, not vague memory, but faithful memory, arriving after the fact. And memory has its own kind of beauty. A childhood home may no longer exist, yet a photograph still holds it. A voice may be absent now, yet an old recording still carries its warmth. A distant galaxy may be beyond any possible future visit, yet light from its earlier life can still reach us, letting us know that it was there, that it shone, that it once belonged to a more connected universe. This does not make the observation meaningless. Quite the opposite. It makes it precious. Because what we receive from the deep cosmos is not nothing. It is evidence. It is history. It is structure preserved in transit. Ancient photons crossing billions of years to tell us what the universe once looked like. But it also asks something difficult of us. It asks us not to confuse a trace with an open road. This becomes even more important when people casually say things like, "If we can see it, maybe one day we can go there." That intuition is understandable. It comes from a human-scale way of thinking. Visibility suggests possibility. But in the expanding universe, visibility can be a kind of afterglow. A delayed notice from reality. Not an invitation. Imagine standing in a wide valley at night and hearing music from a festival far away. The sound drifts to you long after the musicians played the notes. You know something happened there. You know it was real. The music reaches you. But perhaps the bridge that once led across the river has already fallen. The sound arrives. The path does not. That is the mood of much of the sky. And this is exactly why cosmologists distinguish between what is observable and what is accessible. The observable universe is the region from which light has had time to reach us since the beginning of cosmic history. The accessible universe is smaller. It is the region that can still participate in exchange with us from now forward, despite expansion. These are different boundaries, different stories, different meanings of there. If you blur those meanings together, the universe seems simpler than it is. If you separate them carefully, the universe becomes stranger, but also more honest. You begin to see why the phrase "already lost beyond reach" is not exaggeration. It does not mean invisible. It does not even mean unknown. It means disconnected in the future tense sense that matters most for travel, communication, and shared destiny. You can still see the lighthouse. You cannot sail to its present shore. And perhaps the deepest surprise is how ordinary this delay feels once you notice it. We are used to it without really admitting it. Every act of seeing is an act of receiving old light. Even in the room around you, light takes a tiny amount of time to move from object to eye. The delay is just too small to matter. The cosmos did not invent the principle. It only magnified it until it became impossible to ignore. So in a very gentle sense, the whole universe teaches the same lesson at every scale. To see is always to see slightly late. The only question is how late. On Earth, the answer is effectively now. Across the solar system, it is minutes or hours. Across the stars, years. Across galaxies, millions to billions of years. Across the observable universe, it becomes a deep encounter with ancient time, where what we witness may belong to an era whose present continuation is forever hidden from us. This is why the sky can be both revelation and elegy. It reveals what existed. It withholds what exists now, in full. And still, perhaps there is something calming in this once the first strangeness passes. Because it reminds us that knowledge does not always require possession. We do not need to reach everything to learn from it. We do not need access to every shore to understand the tides. Ancient light, even when it arrives from places we will never touch, still expands the mind. It still tells us where we came from, It still gives us a sense of the larger story in which our own small world is embedded. That, too, is a kind of relationship. A limited one, yes. A one-way one, sometimes. But real. The lost universe is not completely silent. It still glows. It still sends traces from its earlier chapters. We can still read those traces with care, with patience, with wonder. We can still look up and understand that the darkness is not empty, but layered with histories arriving out of order. And maybe that is enough to make the visible night feel even more beautiful, not less. Because it is no longer just scenery. It is communication stretched to its limit. A vast archive of delayed existence. A reminder that the cosmos is generous with evidence, even when it is strict about access. If these quiet explorations help ease you into sleep, you can gently leave a like, subscribe, or mention where you're listening from tonight. I always enjoy imagining these distant ideas arriving in so many different corners of the world, a little like starlight itself, traveling quietly into the dark. And in the next part, we move one step deeper. Because once we understand that seeing and reaching are not the same thing, we need to ask what caused this separation to become so extreme in the first place. How did distance stop being simple? How did the universe turn space itself into something dynamic, something that stretches while light is still on the way? That is where the story begins to shift from the poetry of delayed light to the machinery beneath it. And once that machinery comes into view, the whole idea of distance changes again. Part 4. How expansion changes the rules of distance. Distance sounds like such a simple word. A quiet, practical word. The distance between two trees. The distance between two cities. The distance between your home and the sea. In ordinary life, distance feels stable, measurable, reliable. If something is 10 kilometers away, it stays 10 kilometers away unless either you move or it moves. The space between things is treated like an empty stage, silent and still, while the real action belongs to the objects upon it. That is the assumption most of us carry without even noticing. And on human scales, it works beautifully. It works so well, in fact, that it is difficult to imagine the universe asking us to abandon it. But on the largest scales, the cosmos does ask exactly that. It asks us to let go of the idea that space is merely a passive background. It asks us to accept that distance is not always fixed, and that the emptiness between galaxies is not empty in the way we instinctively think. It can stretch. It can grow. It can change while light is traveling through it. And once that happens, distance is no longer just a number. It becomes a process, a living separation, a gap that is not simply there, but becoming. That is the strange shift we begin to explore here. Not just that the universe is large, but that its largeness is dynamic. Not just that galaxies are far apart, but that the very meaning of far apart changes when space itself expands. If you sit with that idea long enough, it quietly rewrites almost everything. Because if space can stretch, then a journey is no longer just about how quickly you can cross a fixed gap. It also becomes about whether the gap itself is widening while you travel. And if the widening is strong enough, then the familiar logic of movement begins to fail. The destination is not merely far away. It is receding through the growth of space itself. To feel why this matters, it helps to begin with the old picture we tend to imagine by default. When many people first hear that galaxies are moving away from us, they picture something like an explosion. A firework, perhaps, with sparks flying outward into a dark void. Each galaxy becomes a kind of fragment, launched long ago and continuing to race through pre-existing space. In that image, space is still just the stage, and the galaxies are the actors dashing across it. It is a vivid picture. It is also, at the deepest level, misleading. The expanding universe is not best understood as matter flying outward into an empty external arena. There is no meaningful center from which everything exploded into surrounding nothingness. There is no outer wall toward which the cosmos expands. Instead, what changes is the scale of space itself. The fabric between distant galaxies stretches, carrying them apart even when they are not moving through local space in the way our instincts imagine. This is why cosmologists so often return to simple analogies. Not because the universe is simple, but because our instincts were built for forests and roads, not for spacetime. One of the gentlest analogies is the raisin bread from the first part. Imagine a loaf of dough rising in the oven. Small raisins are embedded throughout it. As the dough expands, every raisin sees every other raisin getting farther away. The farther away one raisin is from another, the more dough there is between them to stretch, and so the faster their separation increases. No raisin needs to crawl through the dough for this to happen. The dough does the work. Or picture dots painted onto the surface of a balloon. As the balloon inflates, each dot sees all the others move away. Again, there is no special central dot on the surface itself. Every point experiences the same overall pattern. The expansion belongs to the surface, not to the dots choosing to travel across it. These analogies are limited, of course. The universe is not dough, and it is not the two-dimensional surface of a balloon. But they point us in the right direction. They help us loosen our old assumption that distance is a fixed stage on which objects merely act. In the cosmos, the stage can stretch. And that changes the rules. To understand how deeply it changes them, let us slow down and think about what distance usually means. In everyday life, if one town is 50 kilometers away and you drive toward it at 50 kilometers per hour, then absent traffic and detours, you will arrive in about an hour. The road does not normally lengthen beneath your wheels. The kilometers do not multiply while you travel. There is a beautiful simplicity to that. The universe preserves that simplicity only on smaller scales, where gravity keeps systems bound together. Within a galaxy, for example, stars are not being dragged away from one another by cosmic expansion in any noticeable everyday sense. Within the solar system, the planets are not steadily fleeing the sun because of dark energy. Within your room, your furniture is not drifting apart. The forces that bind such systems together are enormously stronger than the gentle stretching of space on those scales. That is an important detail, because it prevents a common misunderstanding. Cosmic expansion is not a kind of universal tearing that rips apart everything from galaxies to atoms. It acts most clearly over the immense, relatively empty distances between large gravitationally unbound structures. Between galaxy clusters, between distant galaxies, across the huge spans where local binding has no power to hold the geometry fixed. So when we say the universe is expanding, we are speaking mainly about the great in-between, the vast dark intervals, the quiet architecture separating one island of structure from another. And those intervals are enough to change the future of the cosmos. Once the space between distant galaxies stretches, distance stops being a simple label and starts becoming a time-dependent relationship. A galaxy may be one distance away when light leaves it, another while the light is en route, and another by the time the light finally arrives. The number is not frozen. It evolves. This alone is a little disorienting. We are used to asking, how far away is it? As though the answer should be a single clean value. In cosmology, that question often comes with several possible meanings. Do you mean how far away it was when the light was emitted? How far the light traveled during its journey? How far away the object is now, after space expanded while the light was on the move? These can be very different numbers. A galaxy whose light has traveled for billions of years may now be vastly farther away than a simple multiplication of distance and time would suggest, because the space between us and the galaxy has continued stretching throughout the journey. This is why the universe resists our ordinary language. The words are familiar, but the meanings keep slipping into stranger territory. And from this simple fact, one of the most important consequences follows. The farther something is, the more strongly expansion affects its separation from us. That sounds almost obvious after the raisin bread analogy, but it contains the seed of nearly everything that comes later. If there is more space between two distant galaxies, then there is more space available to expand. And if more space is expanding, then the overall rate at which the galaxies separate increases. This is what Edwin Hubble discovered in the broadest sense. More distant galaxies tend to recede faster. It was not because Earth sits at the center of a cosmic blast. It was because in an expanding universe, large distances naturally produce larger recession speeds. You can almost think of each stretch of space contributing its own tiny part to the separation. A little bit here, a little bit there, another little bit beyond that. Individually, each local contribution is not alarming, but over enormous distances, they add up. And eventually, the total recession becomes extraordinary. This is where the old meaning of distance quietly starts to break apart. Because if a destination can recede faster simply by virtue of how much expanding space lies between it and you, then remoteness is no longer passive. The gap itself gains agency. Not conscious agency, of course, but geometrical consequence. The more distant the place, the more the universe works to increase the separation. And so the journey becomes a contest. Not just traveler versus distance. Traveler versus distance that is actively changing. Light itself enters that contest. This is what makes cosmology feel so strange. We are used to treating light as the final answer to remoteness. Nothing outruns it. Nothing catches up to it. It is the great messenger of the universe. But in an expanding cosmos, the question is not whether anything locally outruns light. The question is whether the accumulated stretching of space over vast regions can keep increasing the overall separation despite light doing exactly what light always does. And the answer, as we have been approaching part by part, is yes. This is not a failure of relativity. In fact, it is one of relativity's most profound consequences. Einstein's theory forbids matter or information from moving through local space faster than light. It does not forbid the large-scale geometry of space from evolving in such a way that distant separations increase faster than a light beam can compensate for. That distinction matters. It is the difference between a car speeding down a road and the road itself being extended while the car moves. The car obeys its speed limit. The situation still becomes impossible. Once you feel that distinction, you begin to understand why the phrase beyond reach is not melodramatic at all. It is simply what happens when the changing structure of spacetime overpowers the possibility of future contact. Still, there is a softer way to think about it, one that makes the emotional tone of the idea clearer. Imagine two people walking toward each other on a long moving bridge. If the bridge beneath them is stable, their meeting is just a matter of time. If the bridge slowly stretches, they may still meet, but later than expected. If the stretching grows stronger and stronger, there comes a point where each person can keep walking, and yet the distance between them no longer shrinks. Push the stretching further still, and they begin to drift farther apart even as both continue their efforts. The key tragedy is not that either person failed to walk. It is that the geometry beneath them changed the meaning of walking. That is what expansion does to distance on cosmic scales. It changes what effort can mean. It changes what motion can accomplish. And once the universe's expansion began accelerating, this whole story became even more severe. For a long time after the Big Bang, the expansion was real, but gravity was still fighting it on the largest scales. Matter pulls matter. The contents of the universe were trying, in a way, to slow the outward separation. If the cosmos had contained enough matter and no dark energy, the expansion might have decelerated forever, perhaps still expanding but ever more gently. In such a universe, distance would still be dynamic, but the future might have remained more forgiving. Instead, something else came to dominate: dark energy. The name is simple, but the mystery is enormous. We do not really know what dark energy is in the deepest sense. We know it from its effect. It behaves like a kind of persistent influence built into space itself, causing the expansion of the universe to accelerate. Not merely continue, but speed up over time. And once acceleration enters the picture, distance becomes more than a widening interval. It becomes an interval whose widening grows increasingly decisive. That is the heart of why the region beyond reach exists at all. If the universe were expanding but slowing down enough, perhaps more destinations would remain open to future contact. But in an accelerating universe, some of the doors begin to close permanently. The farther regions are drawn outward not just by expansion, but by expansion that grows more dominant as the cosmos ages. This means the rules of distance are not only strange, they are historically changing. We live in a universe whose geometry has had different phases. A hot, dense beginning, a long era shaped heavily by matter and radiation, and now, on the grandest scales, an age increasingly governed by accelerated expansion. So when we look outward, we are not only seeing far places, we are looking across a universe whose very idea of separation has evolved. That has consequences not only for travel, but for visibility, communication, and the future of knowledge itself. A galaxy far away is not simply a landmark waiting to be visited. It may be a place already sliding into causal solitude. Its old light can still make the journey. Its present reality may not. And that difference emerges because distance no longer sits still. In a way, the most important shift is this: in ordinary life, distance is descriptive. In cosmology, distance can be destiny. It helps decide whether futures remain shared, whether messages can still arrive, whether a civilization over there, no matter how advanced, could ever receive a greeting from a civilization here, whether the universe remains one connected domain, or slowly becomes a collection of isolated islands. That last image matters because the cosmos, on the largest scales, really does begin to resemble an archipelago under separation. Galaxies bind into groups, groups into clusters, clusters into vast filaments and walls. But the great expanding spaces between these structures continue to stretch. Over unimaginable times, the local islands remain, while the sea between them deepens into permanent distance. And so a subtle but profound truth emerges. Expansion does not just make the universe bigger. It makes access rarer. It turns the map into something more fragile than it looks. And perhaps this is why cosmology can feel both majestic and faintly melancholic. The universe is not merely a giant place waiting to be explored. It is a changing place, in which the ability to explore is itself time-sensitive. There are eras in which more of the cosmos is mutually available, and later eras in which less remains within reach. We happen to live during one of the earlier, more revealing windows. The sky is still rich with galaxies. The evidence of expansion can still be measured. The broader story of the cosmos is still visible to us. But even now, the structure of distance is already filtering what remains part of our future and what does not. That is a humbling thing to realize. Because it means our intuition, so reliable on Earth, becomes deeply incomplete in the universe at large. We imagine distance as something to overcome with enough patience and enough technology. The cosmos answers gently, but firmly, that this is not always so. Sometimes the obstacle is not the weakness of the traveler, but the changing geometry of the world itself. And yet there is something calming in understanding this. Strange, perhaps, but calming. Because the universe is not being hostile. It is not taking things away out of malice. It is simply unfolding according to the properties of spacetime. It is obeying its own quiet mathematics. Galaxies drift. Light travels. Space stretches. And from those simple ingredients, a vast and beautiful structure of possibility and loss emerges. We are small within it, certainly. But not powerless in the most meaningful sense. We can still understand it. We can still trace the rules beneath the darkness. We can still sit under the night sky and know that what looks still is not still, that what looks fixed is not fixed, and that the great distances overhead are not sleeping numbers, but living relationships changing as the universe grows. If these slow journeys through science help you unwind, you can gently subscribe, leave a like, or share where you're listening from tonight. I always enjoy imagining these ideas traveling quietly into different rooms around the world, while the larger universe keeps stretching beyond them all. Because the next step in the story takes us to one of the most haunting ideas in modern cosmology. If distance itself can change, then where exactly is the boundary between what can still matter to our future and what has already slipped beyond it? Where is the line between a galaxy that is still part of our possible cosmic conversation, and one that has already been carried too far away? That is where we arrive next. At the edge of the future. At the horizon that does not mark what we can see, but what we can still, even in principle, ever reach. Part 5, The Edge of Our Future, the Cosmic Horizon. There is a certain kind of line we are trained to trust. A shoreline in the distance. A mountain ridge against the sky. The place where the sea seems to meet the air. We call it the horizon, and even as children, we learn its quiet trick. It looks like an edge, but it is not really an ending. It is only the limit of what we can see from where we happen to stand. If we walk farther, the horizon moves with us. If we sail toward it, it opens. If we climb higher, it expands. In the ordinary world, a horizon is not a prison. It is an invitation. It tells us there is more. And perhaps that is why the cosmic version feels so strange. Because the universe also has a horizon, but unlike the one at sea, this one is not simply the edge of our current view. It is not a line that patiently retreats as we advance. It is not a temporary limit waiting to be overcome by a taller ladder, a stronger telescope, or a braver voyage. The cosmic horizon we are approaching now is something much more unsettling. It is the edge of our future, not the boundary of what exists, not even just the boundary of what we can observe, but the boundary of what can still, from this moment forward, ever remain in causal contact with us. And that single difference changes everything. Because once you begin to understand the cosmic horizon, the universe no longer feels like an endlessly open landscape. It begins to feel more like a great illuminated map with certain roads quietly closing, not because of war, not because of neglect, but because space itself is changing too quickly for all paths to remain connected. This is a difficult idea to feel all at once, so let us move gently. When most people first hear the word horizon in cosmology, they imagine the limit of visibility, the farthest point from which light has had time to reach us since the beginning of the universe. And that is indeed one kind of horizon. It matters very much. It gives us the observable universe, the enormous sphere of ancient light surrounding us, the largest realm we can study in principle. But that is not the horizon we need most right now. The horizon in this part is subtler and, in a way, more emotional. It is the boundary between a universe that can still become part of our future and a universe that cannot. It marks the farthest regions from which a signal sent now could still, eventually, make its way to us. Or the farthest regions we could still, in principle, ever influence by sending something out from here. That is why this horizon is not just about sight. It is about relationship. It is about whether two places in the cosmos still belong to one another in the only way the future can recognize, through possible exchange. You can think of it as the line dividing the universe into two quiet categories. Inside the horizon are places that remain part of the reachable future, however slow and difficult the path might be. Beyond the horizon are places that may still shine in our sky, may still appear in our telescopes, may still leave behind traces of their ancient existence, but can no longer enter into any new conversation with us. Their old light may arrive. Their present will not. That is the edge of our future. To make this feel less abstract, it helps to return to a very simple image. Imagine a wide river, calm at first glance, but with an invisible current growing stronger farther from shore. A swimmer close to the bank can still fight the current and return. A swimmer farther out has a harder time, but perhaps still has a chance. Then there comes a line, not painted on the water, not visible from above, beyond which the current becomes too strong. Beyond that line, even if the swimmer turns immediately, even if they use every bit of strength they have, they will never again reach the shore. The cosmic horizon is something like that. Not a wall. Not a glowing barrier. Not a sudden cliff in space. Just a threshold where the expansion of the universe becomes too powerful, over too much distance, for future contact to remain possible. And one of the quietest tragedies in all of science is that the sky does not tell us this directly. Nothing in the beauty of a deep field image announces which galaxies still belong to the future and which ones do not. The light arrives with no warning label. Some distant galaxy may look like a delicate spiral in a black sea, serene and perfectly present. And yet, if it lies beyond the cosmic event horizon, no light it emits today will ever reach us. No journey starting now will ever arrive there. It still appears within our awareness, but it has already slipped out of our future. This is why the horizon matters so much. It is not just a technical boundary. It is a profound correction to the way visibility tempts us to think. It tells us that the universe we can see is not identical to the universe we can still share a future with. And that, perhaps, is one of the strangest realizations modern cosmology has given us. Because human beings are used to horizons that yield. We cross rivers. We cross deserts. We cross oceans. We walk to the line where the land seemed to end, only to find another landscape waiting beyond it. Again and again, our history has taught us that the far edge of sight is not final. It is temporary. The cosmos offers a rarer lesson. Sometimes the horizon is real. Sometimes the line is not merely where vision stops, but where participation stops. That is much harder for the imagination to accept. And perhaps that is why it is useful to compare the cosmic horizon, very gently, to something else many people have heard of before, the event horizon of a black hole. A black hole's event horizon is the boundary beyond which nothing that happens inside can send information back out to the wider universe. Once something crosses it, the connection is broken in a one-way sense. To an outside observer, the object has passed beyond the point where future rescue or future communication remain possible. The cosmic event horizon is not the same kind of object, and we should be careful not to force the analogy too far. There is no singularity waiting beyond it, no monstrous gravity well swallowing galaxies. But the emotional logic is similar. There is a boundary beyond which events can no longer influence us, and we can no longer influence them. Not because they vanish, and not because they stop being real, but because the geometry of the universe has made the path between us permanently unworkable. That is why the phrase event horizon appears here at all. It is not about what exists. It is about which events can still matter to one another. And if that sounds almost philosophical, that is because cosmology often becomes philosophical the moment its mathematics begins touching the structure of connection itself. Let us come at it from another angle. Imagine sending a beam of light outward into the universe. Not a spaceship. Not a radio wave from a realistic antenna. Just a perfect pulse of light, moving at the fastest speed nature allows. We might imagine that with enough time, that light should eventually reach any destination, as long as the universe remains around long enough. But that intuition only works if the distance behaves passively. If the gap stays fixed, or at least does not grow too aggressively, then yes, the light can keep making headway. Slowly or quickly, it still wins. But if the space between us and the destination continues expanding, and expanding in such a way that the total separation is driven outward too effectively, then even a light beam can lose the race. It moves locally as light always does, faithfully, relentlessly, at the cosmic speed limit. But the destination is being carried away by the changing geometry of space, not dodging, not accelerating under its own engines, simply participating in the expansion of the universe. And beyond a certain distance, that is enough. The road grows faster than the traveler can shorten it. The future closes. That closing distance is what gives the cosmic horizon its meaning. Right now, in the broad language of modern cosmology, that horizon lies at a distance of roughly 18 billion light-years from us. The exact wording and measurement can become technical depending on how one defines distance in an expanding universe, but the deeper point is simple. There is a finite boundary to our future reach. Beyond it are galaxies from which newly emitted light will never arrive here. Beyond it are places we may still observe in their old forms, but cannot ever newly contact. In other words, the cosmic horizon is not at the edge of the observable universe. It sits well inside it. That is one of the most surprising facts. The observable universe, the vast sphere filled with ancient light, stretches much farther than the region that remains causally accessible to us in the future. So the cosmos gives us this strange condition in which we can look beyond the edge of our future. We can receive postcards from places that have already left the zone of possible exchange. That makes the visible universe feel almost double-layered. There is the outer layer of appearance, the giant archive of what has been seen. And then there is the inner layer of continued possibility, the smaller realm that still belongs, in principle, to the future conversation. Everything beyond that inner line is not invisible, but it is, in a very real sense, unreachable. And the horizon is not static in any comforting way. As the universe continues to age under accelerated expansion, more and more galaxies slip across this boundary. Each one becomes less like a distant neighbor and more like a historical trace. Each one joins the vast inventory of places we can still study in old light, but never meet in the present tense. The process is slow, so slow that no human life can feel it directly. But cosmic history is patient. It does not need drama to change everything. This is one reason why the horizon can feel haunting. It is not an explosion, not a collapse, not a sudden apocalypse. It is simply a quiet sorting of the cosmos into what remains part of our future and what does not. A silent narrowing of the reachable world. Every year, without ceremony, more of the universe passes that line. Nothing seems to happen in the sky. And yet the structure of possible futures changes. There is, perhaps, a human resonance to that idea. Not because the universe is human, but because we understand, in our own way, what it means for a door to remain visibly present and yet no longer be open. A house can still stand after the road to it is washed away. A voice can remain on a recording after the person is gone. A distant coastline can still catch the evening sun long after the currents have become too dangerous for any boat to return. The cosmos has its own version of that sadness. A galaxy may still glow, but the shared road may already be lost. And still, the horizon is not only sad, it is also clarifying. It tells us something important about our moment in time. We live during an era when the sky still reveals more than the future will retain. We are early enough to witness a universe crowded with galaxies, clusters, and large-scale structures. We can still infer the Big Bang. We can still measure expansion. We can still detect the broad architecture of the cosmos. But this is not guaranteed forever. In the unimaginably distant future, the horizon will continue doing its work. More of the universe will slip out of view entirely, or remain only as unreachably redshifted remnants. The grand cosmic story will become harder to reconstruct. Future astronomers, if any exist in that distant era, may inherit a lonelier sky. They may not have the same evidence we do. Their universe may appear smaller, emptier, more self-contained. And so, quite unexpectedly, the cosmic horizon makes our own era feel precious. We are living in a time when the universe still reveals both its vastness and its loss at once. We are late enough to understand the horizon, but early enough to still see what lies beyond it. That combination is rare. And perhaps that is why learning about the cosmic horizon does not merely add a fact to your mind. It changes the mood of reality. It turns the night sky into something more delicate. The stars and galaxies overhead are no longer just decorations scattered across a black ceiling. They become participants in a larger drama of connection and separation. Some remain part of the future web. Others are already drifting into permanent historical distance. Once you see that, the universe feels less like a static kingdom and more like a living coastline under retreating light. The edge is not where things stop existing. It is where futures stop touching. That is the true emotional power of the cosmic horizon. And perhaps it also explains why the word horizon still works so beautifully, even here. On Earth, the horizon reminds us that we are finite creatures looking out into something larger. In cosmology, the horizon reminds us of something more exact and more severe. It reminds us that not all largeness remains available. Some of it can be seen but never reached. Some of it can influence our past without participating in our future. We stand, in other words, at a very unusual vantage point. We are creatures inside the universe who have become aware that the universe is not equally open in all directions of time. That is an extraordinary thing to know. And maybe, once the strangeness settles, even a comforting thing to know. Because it means the cosmos has structure. It means the loss is not random. It follows rules. The horizon is not an act of cruelty. It is a consequence of expansion, geometry, and the deep behavior of spacetime. It can be understood. And there is something deeply calming about understanding even a severe truth. The sea may still be dangerous. But once you know where the current changes, the map becomes clearer. If these quiet journeys through the universe help you drift into rest, you can gently subscribe, leave a like, or mention where you're listening from tonight. I always enjoy imagining these ideas moving softly across different parts of the world, while beyond us all, the wider cosmos continues its slow and silent unfolding. And in the next part, we will step into the scale of this loss more directly. Because it is one thing to understand that there is a horizon. It is another to ask how much has already crossed it. How large is the region that has already slipped beyond our future? How many galaxies are no longer destinations, but only memories carried by light? That is where the numbers begin to feel almost unreal. And where the phrase already lost beyond reach reveals just how vast the loss truly is. Part 6. How much has already slipped away? There is a strange limit to the human mind. Not a flaw, exactly. More like a softness in the way we are built. We can understand the idea of one missing thing. A lost key. A missed train. A house left behind. We can even understand a few hundred, or a few thousand, though already the details begin to blur. But when the numbers grow too large, they stop feeling like quantities and start behaving like fog. We can repeat them. We can write them down. We can nod as though they have entered us. But inside, something remains untouched. The scale passes through language without quite settling into feeling. And that is especially true in cosmology. Because the universe is always offering us numbers that the mind can technically accept, but almost never truly inhabit. Billions of stars. Trillions of galaxies. Distances so vast that light itself needs millions or billions of years just to cross a fraction of the gap. The words go in. The reality stays far away. And perhaps that is why this part matters. Because once we understand that there is a cosmic horizon, the next question becomes unavoidable. Not just is there a boundary, but how much has already passed beyond it? How large is the region that is no longer part of our reachable future? How much of the visible universe is still, in any meaningful sense, open to us, and how much is already only a fading historical record? The answer is so large that it almost feels like a trick of perspective. But it is not a trick. It is one of the deepest facts about the universe we live in. Most of what we can, in principle, see is already beyond our reach. Not a little of it. Not a distant fringe. Most of it. That is the unsettling truth. When cosmologists work through the geometry of an accelerating universe, the conclusion is breathtakingly severe. Of all the galaxies inside the observable universe, only a small fraction remain within the region that could ever still be reached, even in principle, by anything leaving us now at the speed of light. The rest are already outside that future conversation. Their ancient light can still arrive. Their present reality cannot. A commonly cited way of expressing this is the one we touched earlier. Roughly 94% of the galaxies in the observable universe are already beyond our reach. That number does not sound real at first. 94%. It sounds like a rounding error in the wrong direction. A statistic you expect to hear and then discover was exaggerated, or misquoted, or based on some narrow definition. Surely not that much. Surely the lost region cannot already include nearly everything. But it does. And the reason it feels so hard to accept is that the night sky does not look like a universe 94% gone from our future. It still looks rich, layered, open. It still gives the impression of a vast map, not a largely closed one. Telescopes keep revealing more and more galaxies, more and more structure, more and more evidence of a cosmos full of things. Discovery makes the universe feel abundant. And it is abundant. That is the painful part. The loss is not of a sparse universe. It is the loss of an overwhelmingly rich one. The observable cosmos is thought to contain on the order of trillions of galaxies, perhaps around 2 trillion by some estimates, depending on how faint and small a galaxy one is willing to count. Some are giants, containing hundreds of billions or even trillions of stars. Others are dwarfs, scattered like cosmic embers around larger structures. They exist in clusters, in filaments, in long web-like strands spread across the darkness. There is no shortage of architecture out there. No shortage of worlds, histories, mergers, black holes, nebulae, dead stars, newborn stars, and vast regions of matter whose stories unfolded without ever touching ours. And yet, if we ask a different question, not, how much can we see, but, how much can still be part of our future? The answer becomes abruptly smaller. The reachable universe is not the same as the visible universe. It is a smaller inner chamber inside a much larger glowing shell of ancient light. And that means the overwhelming majority of galaxies we can identify are not future destinations at all. They are, in the deepest sense, relics of connectivity. Remnants of a time when the universe was more mutually available than it is becoming now. To feel this more clearly, it helps to move away from the raw percentage for a moment and imagine the number in simpler terms. Suppose you were handed a catalog of 100 galaxies, selected from across the observable universe. To your eyes, each one would seem like part of the same cosmic inventory. Each one would appear as a legitimate member of the universe you can know. But hidden beneath that catalog is a more severe truth. Out of those 100 galaxies, only around 6 would still belong to the realm of possible future contact. The other 94, despite still being visible in old light, would already be beyond the reach of any signal sent now. 6 out of 100. That means if you turned each galaxy into a tiny lantern and lit them all across a black field, almost every light you saw would belong to a place already gone from the future. Not gone from existence. Gone from access. Gone from the possibility of arrival. Gone from the possibility of reply. That is a different kind of loss than most people imagine when they first hear about cosmic expansion. They imagine galaxies becoming harder to visit in some unimaginably distant tomorrow. But the deeper truth is that the sorting has already happened on a massive scale. We are not waiting for the universe to become mostly unreachable. We already live in that condition. And the mind resists this because visibility keeps whispering the opposite. If we can still detect the light, if our instruments can still map the structures, if the pictures are still there, then emotionally it feels as though the destination remains part of the same world as us. But once again, the sky is kinder in appearance than it is in geometry. It keeps sending the past, and the past creates an illusion of openness. We are looking into a vast museum of delayed light. That museum is real. It tells us extraordinary things. It lets us reconstruct the history of stars and galaxies and cosmic structure. But much of what it displays no longer belongs to the set of places with which any future relationship can still be formed. This is why the scale of what has slipped away is not just a matter of counting galaxies. It is about counting futures. Each unreachable galaxy is not merely an object on a list. It is an entire region of possible history cut off from all future exchange with us. Countless stars, countless planetary systems, possibly endless variations of chemistry, geology, and whatever else the universe invents in its quieter corners. Perhaps lifeless, perhaps not. We do not know. And in many cases, we will never know in the present tense sense, because the channel by which new information could arrive is already closed. It is worth pausing there, because it adds another layer to the loss. When we say most galaxies have slipped beyond reach, we are not saying we have lost the chance to sightsee. We are saying we have lost the chance, even in principle, to ever know their later story. Their present and future unfold outside our causal neighborhood. Whatever happens there now, or billions of years from now in their local histories, will not become part of ours. There is something almost literary about that. Entire chapters continue to be written in the universe, but the pages can no longer be delivered, and the scale keeps growing. That, perhaps, is the most difficult part of all. The 94% is not some final settled figure after which the universe pauses and lets us catch our breath. The horizon continues doing its work. More galaxies cross out of the reachable domain as cosmic expansion proceeds. The visible universe remains rich with ancient light, but the accessible universe narrows relative to that richness. The archive stays large for a long time. The set of still open futures becomes progressively smaller. This process is not dramatic on a human timescale. There is no night when people wake up and say the sky looks different. No ordinary observer notices a galaxy quietly becoming cosmologically unreachable. But on the timescales that shape the fate of the cosmos, it is relentless. Some estimates capture this with another startling image. Every year, the expansion of the universe pushes roughly the equivalent of about 160 billion stars beyond our cosmic event horizon. Even that phrase is hard to feel properly. 160 billion stars. In a single year. Not exploding. Not being destroyed. Simply crossing a threshold of future contact. Slipping beyond the region from which light emitted now could ever still make its way back to us. To put that in softer terms, the universe is shedding reachable starlight all the time. A silent outward drift. A continual surrender of destinations. And it does so without noise. This is one reason the subject carries such a calm sadness. If the universe lost itself in violence, perhaps the mind would recoil and then move on. But cosmic loss is often patient, gradual, measured. It gives us no spectacle to mark the moment. It lets the unreachable remain visible for ages, like a face remembered long after the person has boarded the last train out of town. The result is that what has slipped away already is both enormous and oddly hard to mourn, because the evidence of its disappearance still shines. We can still admire the distant spiral galaxy in a telescope image. We can still talk about its redshift, its mass, its age, its structure. We can still teach students about what galaxies looked like in the young universe. None of that stops. The light keeps arriving for a very long time. But if we ask a stricter question, a future question, a question about whether anything sent now could still ever catch up, the answer has already turned against us for most of the cosmos. This reveals something important about the phrase, already lost. It does not mean, already absent from view. It means, already absent from possibility. That is a much quieter kind of disappearance, and perhaps a deeper one. If a city burns, its loss is obvious. But if the road to it is erased while its radio station continues to play recordings from months ago, the loss is stranger. The signs of life remain. The connection does not. That is much closer to what cosmology is telling us. We are receiving recordings from the broader universe, not live access. And because the numbers are so large, we need analogies just to keep the feeling from evaporating. Imagine the observable universe as a library with 2 trillion books. The shelves stretch beyond anything a person could walk in a lifetime. The books glow softly in the dark, each one the story of a galaxy, full of stars and collisions and quiet ages of light. Now imagine learning that only a small fraction of those books can ever still be revised, answered, or exchanged with you. The rest are sealed editions from a relationship already over. You can still read what arrived. You cannot send new pages back. Or imagine a vast harbor at night, filled with ships whose lanterns still glitter across the water. To the eye, it looks alive and connected. But then you learn that almost all of them are already beyond the turning point of the current. Their lights are still visible. Their paths are not coming back. That is the emotional truth beneath the numbers. And once it settles in, another realization follows. The scale of what has slipped away tells us something not only about the universe, but about us. It tells us that our species has arisen during a peculiar interval in cosmic history. Late enough to understand expansion. Late enough to measure dark energy. Late enough to know that most of the visible universe is already unreachable. But still early enough that the evidence is abundantly present in the sky. We live in a moment when the cosmos still appears larger than our future access to it. That is an unusual privilege. Future observers, in an unimaginably distant age, may not have that privilege. More and more galaxies will fade beyond detectability, their light stretched into wavelengths too long and too faint to be noticed by ordinary means. The cosmic landscape will look emptier. The archive itself will shrink in practice, not merely the accessible portion of it. The enormous loss we are discussing now may no longer even be visible as a loss. It may simply appear as absence. And so, paradoxically, the fact that so much has already slipped away is part of what makes the present era so extraordinary. We are aware of a richness we cannot keep. We are able to see the contours of a universe that later ages may never fully reconstruct. We are cosmic witnesses standing in an age of delayed abundance. That thought can be sad, certainly. But it can also be strangely beautiful. Because it means the sky we inherit is not just scenery. It is evidence. It is a temporary revelation. It is a rare window in which the universe still allows itself to be read on scales that will not always remain available. And perhaps that is why the scale of the loss matters emotionally, not just scientifically. It teaches us that reality is not obligated to remain open simply because it is visible. It teaches us that possibility has a history. That access can shrink while appearance lingers. That the universe, vast as it is not equally available across all eras. There is humility in that lesson. We often imagine knowledge as a staircase that only climbs upward. Learn more, build more, see more, reach more. But the cosmos gives a more delicate picture. Yes, we can learn more. Yes, our instruments can deepen our view. But the physical structure of what remains reachable is changing beneath that learning. The map is not waiting patiently for us to catch up. It is evolving. Some of its roads are quietly leaving while we study the atlas. This does not make astronomy futile. Far from it. It makes it precious. Because to study a distant galaxy whose present has already slipped away is still to recover a true piece of cosmic history. The old light is not fake. It is not meaningless. It is the preserved testimony of what was. And by collecting enough of those testimonies, we have built one of the most extraordinary pictures the human mind has ever assembled. A picture of a universe that began hot and dense, grew structure over billions of years, and is now accelerating into a future of increasing isolation. That picture is worth holding gently. It tells us not only what has been lost, but what remains. Our local group of galaxies remains bound together. The Milky Way, Andromeda, Triangulum, and dozens of smaller companions are still part of one shared gravitational neighborhood. This is our lasting island. While the wider ocean stretches and carries other islands away, our local structures remain, at least for unimaginably long periods, in each other's future. And in that sense, the universe is not taking everything. It is narrowing the larger map while leaving us one enduring archipelago of stars. Still, beyond that island, the losses are immense. Almost every deep cosmic image contains this double truth: beauty and exile, structure and separation, the visible presence of what the future can no longer touch. And maybe that is one reason these ideas can feel almost dreamlike at night. They do not behave like ordinary facts. They behave like quiet revelations. They reach into the imagination not by shouting, but by slowly changing the meaning of simple things: distance, seeing, future, connection. By the time we say the number again, 94%, it no longer feels like a statistic alone. It begins to feel like a condition of existence. We are inhabitants of a universe that is mostly already beyond us. And yet we are also inhabitants of a universe kind enough to let us still see so much of what is leaving. That may be the strangest gift of all. If these slow cosmic journeys help you relax into sleep, you can gently subscribe, leave a like, or share where you're listening from tonight. I always like imagining these ideas moving quietly through dark rooms across the world, while above all of us the night sky keeps carrying its ancient messages. And in the next part, we turn toward one of the deepest questions this loss raises. If light is the fastest thing in the universe, why is even that not enough to save the connection? Why can't light simply bridge the gap forever? Why does the future still close, even for the cosmos's fastest messenger? That is where we begin next. And once we follow light into that question, the strange machinery of the universe becomes even more beautiful, and even more severe. Part 7. Why even light cannot save the situation. Light feels like the universe's great promise. It is fast beyond ordinary comprehension. In 1 second, light can circle the Earth more than 7 times. It reaches us from the moon in a little over a second. From the sun in about 8 minutes. From the outer planets in hours. For almost every scale that touches human life, light seems practically instant, like nature's own form of magic. It is the thing we trust to carry the world to us. Sight depends on it. Astronomy depends on it. Nearly everything we know about the wider cosmos has arrived because light crossed the dark and found us. So when we begin talking about galaxies slipping beyond reach, there is an understandable instinct to push back. Surely light can still make it. Surely if nothing can travel faster than light, then light itself must always be enough. Enough to keep the connection alive. Enough to bridge any gap, given enough patience. Enough to preserve some final thread between us and the distant universe. That intuition is gentle, logical, almost comforting. And it is also, on the largest scales, wrong. This is one of the most haunting truths in cosmology. Not because it is violent, but because it is so calm. The fastest thing in nature is not enough to save the connection. Light can keep moving forever and still fail to arrive. It can do everything physics allows it to do, and still lose the race. That sounds impossible the first time you hear it. It sounds like a contradiction hidden inside the laws of nature. But it is not a contradiction. It is what happens when space itself becomes part of the problem. To feel this clearly, let us slow down and step away from the abstract words for a moment. Imagine a person walking up the down escalator in a quiet airport. If the escalator is moving downward slowly, they can still make progress upward. Each step carries them a little closer to the top. If the escalator moves faster, they struggle more, but still advance. If the escalator moves downward exactly as fast as they walk upward, they remain stuck in place, moving their legs but going nowhere overall. And if the escalator moves faster than they can walk, then no matter how steadily they keep stepping, they are carried farther from the top. Now replace the person with a beam of light. Replace the escalator with expanding space. And replace the top of the escalator with a distant galaxy. That is not a perfect picture, but it points us in the right direction. Light is still moving exactly as light should move, always at the speed nature permits through local space. But the large-scale geometry between here and there is not passive. It is changing, stretching, carrying the destination away while the signal is on its way. And beyond a certain boundary, that is enough to break the future connection. This is the part that often causes quiet confusion, because people have heard, correctly, that nothing can go faster than light. So when they also hear that some galaxies are receding from us faster than light, it sounds as though physics has made a mistake. But the mistake is only in the picture we carry. Einstein's speed limit applies to objects moving through space locally. It tells us that matter and information cannot locally outrun light in the ordinary sense. It does not say that the large-scale distance between two extremely remote regions cannot increase faster than light because of the expansion of space itself. Those are not the same kind of motion. This distinction matters more than almost anything else in this story. If a galaxy were blasting through nearby space past us faster than light, that would indeed violate relativity. But when a very distant galaxy is said to be receding faster than light, what is really being described is not a local sprint. It is the growth of the intervening spacetime. There is so much expanding space between us and that galaxy that the total separation increases faster than a light beam can compensate for. The galaxy is not cheating. The universe is stretching. And once the gap is governed by that stretching, speed alone stops being the whole story. It may help to picture a beam of light trying to cross a cosmic river. Locally, the beam moves exactly as it should, always pressing forward. But the river is broad, and the current is strange. In some regions it is weak, and the beam gains ground. In others it becomes stronger, and the forward progress slows in the larger, global sense. Beyond a certain point, the current wins. The light still moves. But the far bank is carried away faster than the beam can ever approach it. This is why the phrase "light cannot save the situation" is not poetry. It is geometry. And geometry, when stretched across the age and size of the universe, can become more powerful than all our ordinary instincts. One reason this is so difficult to feel is that most of our experience with light has taught us the opposite lesson. Light reveals. Light connects. Light arrives from very far away and turns remoteness into knowledge. Even the stars are proof of that. We sit on a planet around an ordinary star and gather information from objects unimaginably distant, all because photons have been patient enough to cross the dark. Light feels reliable because it has been our great messenger. And in many ways, it still is. But messenger is not the same as rescuer. Light can tell us what once happened. It cannot guarantee that the relationship remains open now. That is the key difference. Ancient light from a distant galaxy may still be arriving, and when it reaches our telescopes it gives the impression of continued connection. Yet that same galaxy may already be so far beyond the cosmic event horizon that any light it emits today will never reach us. We continue receiving the older chapters even after the possibility of receiving new ones has quietly ended. In that sense, the universe is almost cruelly elegant. It allows the past to linger while the future closes. And perhaps that is why the subject feels emotionally sharper than many other facts in astronomy. The lost regions of the universe are not simply blacked out. They are not erased in some obvious dramatic way. They remain visible for a long time. Their old light continues to stream in. The sky lets us keep looking at what the future can no longer touch. It lets us mistake delayed evidence for continued access. That is where light becomes both beautiful and heartbreaking. It keeps us informed, but only about what has already left us behind. If you imagine the universe as an immense conversation, light is the voice carrying across the room. But in an accelerating cosmos, some voices are not really crossing the room anymore. We are hearing echoes, recordings, replies sent long ago. The new words no longer make it over. And that makes the sky feel different. Because the stars and galaxies above no longer seem like equal participants in one shared present. Some are close enough, or gravitationally bound enough, to remain part of our future. Others are already becoming one-way histories. They shine, but the route has failed. To make this clearer, imagine two lighthouses on distant shores. Long ago, both were visible to one another across a broad sea. Their beams crossed the darkness and each knew the other was there. But over time, the sea itself widened, not by waves or storms, but by the stretching of the world between them. At first, the light still made the journey. Then only the light sent earlier could still arrive. Eventually, the widening became so severe that any newly emitted beam was lost in the growing gulf. If one shore kept seeing old flashes from the other, it might still feel as though the connection remained alive. But it would not. That is much closer to what the cosmos is doing. This also helps us understand why the cosmic event horizon matters so much. It is not just the place where a galaxy becomes hard to reach. It is the boundary beyond which newly emitted light from that region will never arrive here, even if we wait forever. Not a billion years. Not a trillion. Forever. That is what makes it an event horizon and not just a large distance. Once something lies beyond that boundary, light is no longer enough to maintain causal contact. And if even light cannot preserve the connection, then nothing else can. No future technology changes that. No advanced civilization solves it by building a better engine. No clever use of energy overcomes it. The problem is not that we are too primitive. The problem is that spacetime itself has arranged the future differently. That realization can feel severe, but there is also a quiet clarity in it. It removes the false hope that every visible thing is just waiting for sufficient progress. Sometimes science gives us more possibility. Here, it gives us a boundary. A real one. A soft-spoken but absolute line in the architecture of the cosmos. Still, there is another layer to this story, one even stranger than the failure of light to catch up. Not only can light fail to bridge the expanding gap, the light itself gets stretched by the expansion as it travels. This is the redshift we touched on earlier, but here it begins to matter in a deeper way. As photons move across expanding space, their wavelengths are stretched. Light that began as visible light may become infrared, then microwave, then radio. Over extreme stretches of time and distance, the signal becomes longer, weaker, more diluted. It does not simply remain unchanged while it travels. The universe works on it, pulls it thinner. So even when light still arrives, it arrives altered by the long expansion of the road. And as the future deepens under dark energy, the light from very distant galaxies is stretched more and more until it becomes extraordinarily faint and difficult to detect. This means cosmic loss happens in two related ways. First, some places are already beyond reach in the causal sense. Second, even the visible traces of those places become increasingly redshifted and ghost-like over time. The messenger not only struggles to arrive, it is gradually thinned into near silence along the way. There is something deeply beautiful in that, if beauty is allowed to include sadness. The universe is not slamming doors. It is dimming conversations, stretching them out, turning clear voices into longer and weaker murmurs until eventually they fall below the threshold of what can be heard. This is why future observers, far beyond our era, may live under a sky that appears much emptier than ours. Not because the rest of the universe ceased to exist, but because the light from it will either no longer arrive in any meaningful way or will have been stretched so severely that the wider cosmic structure becomes hidden from view. They may inherit a local island of stars with little evidence that anything grander lies beyond it. And all of this begins with the simple fact that light, though fast, is not magically exempt from the large-scale behavior of spacetime. In human life, speed usually feels like the answer to distance. Need to get somewhere sooner? Go faster. Need to send information urgently? Increase the speed of transmission. The universe allows that logic on many scales, but not on the largest scales where the geometry itself starts setting the terms. There, speed is no longer the whole answer. Even perfect speed can fail in an imperfectly stable cosmos. That is one of the most humbling lessons in modern science. The cosmos is not only about how fast a thing can move, it is also about what kind of arena movement takes place in, and the arena is not fixed. It evolves. If you sit quietly with that long enough, it changes the emotional tone of light itself. Light stops being only a symbol of certainty and begins to feel more like a traveler moving through a world that can betray distance in subtle ways. Not a weak traveler. Not a flawed one. Just one subject to the deeper rules of the universe. It continues onward faithfully. The path does not. This may be why light is such a perfect messenger for this story. Because it lets us understand both the generosity and the severity of the cosmos. Light is what lets us know the universe at all. It carries the history of stars, galaxies, nebulae, and ancient cosmic structure. It brings us the past with incredible loyalty. But at the same time, its limits reveal that reality is not infinitely open. Some distances stop being bridgeable, not because the messenger failed in courage, but because the future itself has been shaped by expansion. So when we say that even light cannot save the situation, what we really mean is this. The universe has become dynamic enough, on large enough scales, that the fastest messenger in existence can still arrive too late, or perhaps more precisely, can still be denied arrival altogether by the evolving geometry between source and destination. That is a severe thought, but it is also strangely calming once it is understood, because it reminds us that the cosmos follows rules, even in its melancholy. The loss is not random. The fading is not chaotic. Light does not fail out of weakness. It fails because the universe is deeper and stranger than ordinary intuition prepared us for. There is order in the sadness, structure in the silence. The horizon is not an accident. It is an expression of how spacetime behaves when dark energy dominates the future. And perhaps this is one reason why cosmology can be so restful to think about at night. Not because its facts are always comforting, but because its truths are so immense that they quiet smaller anxieties for a while. The mind stops circling its ordinary rooms and steps outside, into a larger architecture where even loss has geometry, even distance has history, and even light has a limit that teaches us something true about the shape of existence. We are small in that architecture, yes, but we are not blind inside it. We can still understand what light is telling us, and also what its failure tells us. We can still sit beneath a sky full of ancient arrivals and know that some of them are messages from places already gone from our future. We can still appreciate the tenderness of that arrangement. A universe so vast, and yet still willing to send us the glow of what it can no longer keep connected. If these quiet explorations help you rest, you can gently subscribe, leave a like, or share where you're listening from tonight. I always like imagining these ideas arriving softly in different places around the world, a little like light itself, traveling patiently through the dark. And in the next part, we step forward into a much lonelier time. Because if even light cannot preserve contact, what will the universe look like to the civilizations who come after us, far in the distant future? What happens when more and more galaxies fade beyond the horizon, and the sky itself begins to lose the evidence of its own past? That is where we are going next. Into the strange future of a universe that has not ended, but has become harder and harder to know. Part 8. What future civilizations would actually see. It is one thing to learn that the universe is expanding. It is another to imagine living so far in the future that the consequences of that expansion have become the normal shape of reality. For us, the sky still feels full. Even if we do not see it with our eyes alone, we know that beyond the stars of the Milky Way there are other galaxies. We know that Andromeda is there, a vast spiral island drifting in the dark. We know that galaxy clusters thread the universe into an immense cosmic web. We know that the night, though black, is crowded with structure. We have telescopes, measurements, redshifts, deep field images, and a whole long chain of scientific understanding that lets us see the universe as something far larger than our immediate surroundings. But what if you were born in a much later age? What if you lived so far ahead in cosmic time that the evidence we take for granted had thinned out, faded away, or slipped beyond the horizon altogether? What would the universe actually look like then? Not in theory, not from the equations alone, but from the perspective of beings standing under that future sky, trying to understand where they are. That is the question of this part, and it leads us into one of the strangest and quietest ideas in all of cosmology. The future universe may not only be emptier, it may be harder to interpret, it may hide its own history. And if that sounds almost unfair, that is because it is one of the rare moments where the universe seems to give a gift to the present by withholding it from the future. We live in a time when the cosmos is still willing to explain itself. Future civilizations may not be so lucky. To understand why, it helps to begin close to home again. Right now, our galaxy is not alone. The Milky Way belongs to a small gathering of galaxies called the Local Group. It is not a spectacularly large region by cosmic standards, but it matters immensely to our future because gravity has stitched its members together tightly enough that cosmic expansion cannot pull them apart. The Milky Way, Andromeda, the Triangulum Galaxy, and dozens of smaller companions remain part of one shared gravitational island. This local island is our lasting neighborhood, and that detail changes everything. Because while dark energy keeps stretching the larger universe, the local group is dense enough and bound enough to resist being dispersed by that expansion. The galaxies within it move under their own gravitational relationships. They orbit, interact, and in some cases head toward mergers that will reshape the future sky. The most famous of those future events is the long-expected encounter between the Milky Way and Andromeda. In around 4 to 5 billion years, the two galaxies are expected to begin merging, not in a sudden crash like cars at an intersection, but in a slow, majestic gravitational dance stretching over hundreds of millions of years. Their stars are so widely spaced that direct collisions between individual stars would be rare, but the structure of both galaxies would be dramatically transformed. Spiral arms would distort. Gas clouds would compress and trigger new rounds of star formation. Tidal streams would wrap the sky in great arcs of scattered stars. Eventually, the two galaxies would settle into one much larger system, often given the informal nickname, Milkomeda. That name sounds almost playful, but the reality it points to is solemn in a cosmic way. Because Milkomeda, or whatever final form this merged galaxy takes, will likely become the central stage of the visible future for civilizations living very far ahead, not because nothing else exists, but because almost everything else will have slipped too far away to remain visible in any useful sense. Imagine, for a moment, that you are one of those future observers. You are not human, perhaps, or perhaps you are descended from beings who once were. It hardly matters. What matters is that you are intelligent, curious, and capable of looking up. Your instruments are sophisticated. Your mathematics is strong. You live in a mature galaxy full of ancient stars, stellar remnants, dark matter, and long histories folded into its structure. You study the heavens as we do. You ask the same kinds of questions. What is the universe? How large is it? Has it always been this way? Are there other galaxies beyond your own? And when you look outward, what do you find? At first, not much. Beyond your home galaxy, the sky appears black, not truly empty, perhaps. There will still be nearby stars, clusters within the merged remnant, the glow of old stellar populations, and whatever planets, nebulae, black holes, and compact remnants continue to inhabit that local domain. But the broader population of external galaxies, the great swarms and filaments we map so easily now, will no longer stand revealed across the heavens. Their light will have been stretched, weakened, and carried so far into the red by cosmic expansion that they effectively vanish from direct detection. The future night sky, in other words, may not advertise the wider universe at all. It may appear as though the entire cosmos is just one great galaxy suspended in endless darkness. And if you think about it, that would change almost everything. Because astronomy is not just about looking. It is about inference. It is about learning from patterns. Right now, when we study the sky, we see that galaxies exist beyond our own. We observe their redshifts. We measure the way distant light stretches with distance. We use those clues to discover expansion. We reconstruct cosmic history from evidence spread across enormous scales. The larger universe is not hidden from us. It leaves fingerprints everywhere. But future civilizations may lose access to many of those fingerprints. No visible swarm of distant galaxies. No easy measurement of cosmic recession. No richly populated deep field to hint at the universe's ancient youth. No obvious evidence that their galaxy is just one member of a much larger cosmic society. That means their cosmology, no matter how intelligent, may begin from a far poorer observational starting point. It is worth pausing here, because this is one of the most extraordinary consequences of cosmic expansion. We often imagine scientific progress as something guaranteed to improve with time. Give a civilization longer, and it will know more. Give it better tools, and it will solve deeper mysteries. But the universe does not promise that the evidence remains equally available forever. Some truths are easier to discover in certain eras than in others. Some windows of knowledge are historical windows. If you miss them, the cosmos does not necessarily leave the curtains open for your descendants. That is what makes our own era so unusual. We live at a time when the universe is old enough to have become structured, but not yet so old that the evidence of its structure has disappeared from view. We still see other galaxies. We still detect the afterglow of the Big Bang. We still observe the large-scale expansion of space. Future observers may inherit better minds, better mathematics, better instruments, and still lack the raw observational clues we happen to take for granted. That is not because they are less capable. It is because the sky they inherit will be poorer in evidence. There is something almost haunting in that. A future civilization could be brilliant and still conclude, quite reasonably, that it lives in a mostly isolated, static, self-contained universe. It might study the stars in its galaxy and discover gravity. It might build a sophisticated physics. It might learn quantum theory, relativity, stellar evolution, black hole thermodynamics, and all manner of deep truths about matter and spacetime. But without a visible population of receding external galaxies, and without accessible evidence of cosmic background radiation in any practical form, its picture of the universe as a whole could remain radically incomplete. In some deep sense, it would be cosmologically lonely. Not only because other galaxies are unreachable, but because their existence might not even be obvious anymore. This is one of the most delicate tragedies in the story of the lost universe. The loss is not merely of destinations. It is also, eventually, the loss of context. The wider cosmos becomes not just inaccessible, but difficult to infer. The future may not only close roads, it may erase signposts. To feel that loneliness more clearly, let us imagine a future observer again. Perhaps they live in a planetary system orbiting an old, dimmer star in the far outskirts of the giant merged galaxy. Their civilization has history, philosophy, science, and long traditions of skywatching. They catalog stars. They map globular clusters. They observe the motions of gas and dark matter in their galactic halo. They know their galaxy is large, ancient, and gravitationally bound. They may even suspect that it formed from earlier mergers, because fossil traces of tidal streams and stellar populations remain inside it. But the great external world beyond it appears still and dark. No obvious Andromeda. No Virgo cluster. No remote spiral smudges in the black. No bright clues that spacetime itself is expanding on the largest scales. If such observers were to ask whether there are other galaxies outside their own, the question might begin to sound speculative rather than empirical. A philosophical possibility. A mathematical suggestion. Not something directly anchored to obvious observation. And this is where the future universe becomes not just lonely, but epistemically lonely. It becomes harder to know what lies beyond the local island. Harder to reconstruct the true scale of cosmic history. Harder to understand that what looks like the whole universe is only the surviving visible remnant of a once far richer scene. For us, the Big Bang is supported by multiple lines of evidence. The expansion of galaxies, the cosmic microwave background, the abundance of light elements, the growth of large-scale structure. These clues reinforce one another. They form a coherent picture. But if a future civilization loses access to the sky in the way we have access to it now, some of those clues weaken or vanish. The cosmic microwave background, for example, will continue to exist, but over vast stretches of time it will be redshifted into wavelengths so long and diluted that detecting it may become extraordinarily difficult, perhaps effectively impossible depending on the local plasma environment and technological constraints. The great primordial afterglow will not disappear in an absolute sense, but it may fade from usable evidence. And if that happens, the universe will become harder to interpret from first principles alone. Future observers might rediscover Einstein's equations and notice that certain solutions suggest expansion. But without external galaxies to measure and without a clear relic radiation background to confirm a hot beginning, they might treat those expanding solutions the way Einstein once did, as elegant but unverified mathematics. Interesting, perhaps, even compelling, but not necessarily the observed truth of the cosmos they see around them. In other words, the future universe may tempt its inhabitants into believing in a static cosmos, not because the universe will actually become static, but because the remaining evidence may no longer clearly betray its expansion. That is such a strange inversion of history. We often think of the past as the time of mistaken certainty and the future as the age of increased understanding. Yet in this case, the deep future may inherit less observational access to the truth than we do now. We, fragile and early and temporary as we are, may belong to a privileged chapter in which the universe still leaves enough of itself visible to reveal its larger nature. That privilege is easy to miss because it hides inside ordinary science. A redshift survey here. A microwave background map there. A telescope pointed at a patch of darkness that blooms into thousands of galaxies. We have become so used to the success of these observations that we forget how era-dependent they really are. The cosmos is speaking clearly to us now. It will not always do so. Still, there is something almost beautiful in imagining that future sky. Lonely, yes, but not dead. Milkomeda, or whatever its true final form becomes, will be a vast system. Its stars will continue their long lives. White dwarfs will cool. Neutron stars will linger like compact memories of violent births. Black holes will sit in galactic centers and wander stellar populations. Old red stars may burn for trillions of years, providing dim but persistent sources of light long after brighter stars have come and gone. Planets may remain. New stars may become rare, but not impossible in all contexts for long stretches. The local universe will still have texture, motion, and history. What it will lack is obvious beyondness. The sense that the night opens into a great society of distant galaxies. The awareness that the local island is one island among trillions. And perhaps that is why the future sky can seem so emotionally powerful when imagined carefully. It is not only the loss of spectacle. It is the loss of scale, the loss of perspective, the loss of a certain cosmic humility that comes from knowing how small our galaxy is compared with the full observable universe. For future civilizations, that humility may have to come from theory rather than sight, or it may never come at all. They may live in a cosmos that appears finite in all the wrong ways, not because it truly is small, but because the rest has been redshifted into silence. There is another subtle consequence too. If observers cannot easily see external galaxies, then the whole concept of cosmic history may feel flatter. The current universe might appear timeless in a way ours does not. Right now, we see galaxies at different distances and therefore at different ages. Looking outward means looking backward. The sky itself becomes a time-layered archive. But if the visible external universe fades away, that archive grows thinner. The sky becomes more local, more immediate, less obviously historical in its largest structure. That means the universe loses not only breadth, but memory. Or perhaps it would be more accurate to say that the memory remains, but much of it is locked away. The future inherits a grand library with most of the shelves darkened. And yet, maybe this thought does not have to be purely sad. There is a different way to hold it. The fact that future civilizations may see less than we do now reminds us that knowledge is not just a triumph of intelligence. It is also a meeting between intelligence and circumstance. We have the extraordinary luck to exist in a period when the universe is both understandable and still visibly rich in evidence. We did not earn that timing. We simply arrived within it. And because we did, we get to witness a cosmos that later ages may only guess at. That gives our own looking a special tenderness. When we study other galaxies, we are not just doing astronomy in the abstract. We are preserving a record from a temporary era of cosmic openness. We are reading what the sky still allows us to read before more of the script retreats beyond easy view. You could even say that we are the witnesses for those future civilizations. We are the ones who still get to see the universe while it remains legible on the grand scale. We are the ones who can still say, with evidence in hand, that the darkness beyond our galaxy is not empty. It is full. Or at least, it was full in ways the future will no longer reveal so easily. And perhaps the most moving part of all this is that the universe does not become smaller in any absolute sense. The broader reality remains there, unfolding beyond the horizon. Galaxies continue their long stories. Clusters evolve. Black holes merge. Stars are born and die. Matter continues participating in the great cosmic drama. The loss is not of existence. It is of access, of visibility, of shared futures and shared evidence. That distinction matters, because it means the future sky will not lie exactly. It will simply omit. It will tell a local truth and conceal a larger one. And omission can be more powerful than denial. A civilization staring into a dark, mostly empty-looking cosmos may not be wrong about what it sees. It will simply be missing the vastness that once stood plainly available to earlier eyes. There is something deeply human in that, even though it belongs to the stars. We know what it is for memory to thin, for evidence to fade, for a once larger story to survive only in fragments. The future universe may experience its own version of that, not in consciousness, but in visibility. Its history becomes harder to recover from the sky itself. So what would future civilizations actually see? They would see their local galaxy, rich with old stars and gravitational structure. They would see a sky increasingly emptied of obvious external galaxies. They would inherit a universe that feels more self-contained than ours. They would likely live in a time when the broad evidence of expansion is dimmer, the cosmic background more elusive, and the larger cosmic web no longer visibly spread before them. And unless they possessed some preserved record from an earlier era, they might never know just how much had once been visible. That is the quiet severity of the future. A universe not destroyed. A universe concealed. If these slow journeys through the cosmos help you rest a little more deeply, you can gently leave a like, subscribe, or share where you're listening from tonight. I always enjoy imagining these ideas arriving softly in different places on Earth, while beyond us, the larger universe continues its long retreat into darkness and memory. And in the next part, we move into the emotional heart of all this. Because what does it actually mean to live in a universe where most of reality is permanently inaccessible? What does that do to our sense of place, meaning, and cosmic belonging? That is where we go next. Into the strange loneliness of an expanding universe, and the quiet philosophical weight of knowing that most of what exists will never truly be ours to touch. Part 9. The strange loneliness of an expanding universe. There is a kind of loneliness that has nothing to do with people. It is not the loneliness of an empty room, or of a missed call, or of standing apart in a crowded place. It is something larger, quieter, and harder to name. A loneliness built not from emotion alone, but from structure, from distance, from the realization that there are things which exist, and may go on existing for ages beyond imagining, and yet can never truly be part of your future. That is the kind of loneliness hidden inside an expanding universe. Not a dramatic loneliness. Not the kind that shouts. A patient one. A cosmic one. And perhaps that is why it lingers in the mind once you begin to understand it. Because by now, the story has changed shape. We are no longer simply talking about stars and galaxies in the abstract. We are talking about a universe in which most of what is real is not merely far away, but permanently inaccessible. A universe in which visibility can survive after relationship has already failed. A universe in which old light continues to arrive from places whose present can never answer back. If you say that too quickly, it sounds almost cold, technical, like one more strange result from theoretical physics. But if you slow down enough, and let it settle, it begins to feel like something else. It begins to feel personal, even though it is not about any one person at all. Because human beings are creatures built for connection, we orient ourselves through relationships. Between one house and another, one city and another, one coastline and another. We look out at the world and instinctively assume that distance, however large, still belongs to one common fabric. We may not be able to cross every sea, but we understand seas as things that can be crossed. We may not be able to visit every country, but we understand countries as places still living inside one shared geography. Even when we look upward, we carry that same instinct with us. The stars seem to occupy a common night. The galaxies seem to belong to one shared sky. And because of that, the universe often feels more connected than it really is. This is one of the deepest emotional consequences of cosmology. Science tells us something our instincts resist. It tells us that reality is not equally available just because it is equally real. That what exists and what can ever become part of our future are not the same set of things. That the cosmos contains not only distance, but separation of a more absolute kind. And once you understand that, the universe becomes lonelier. Not smaller. Not poorer in beauty. Lonelier. Because loneliness, in its deepest form, is not always about absence. Sometimes it is about unreachable presence. About knowing something is there, and knowing at the same time that it cannot be touched, joined, or answered. That is a very different feeling. And it may be the closest emotional analogy to what the expanding universe is doing on the largest scales. There are galaxies beyond our future reach right now. Vast systems full of stars, perhaps planets, perhaps things we can barely imagine, continuing their histories entirely outside the domain of any future contact with us. They are not gone. They are not dead. They are simply elsewhere in a stronger sense than ordinary language prepares us for. Their existence continues without any remaining bridge to ours. That is strange enough scientifically. Philosophically, it becomes stranger still. Because it asks a quiet question. What does it mean to live in a universe where most of reality is permanently unavailable? Not hidden because we are ignorant. Not withheld because we are technologically young, but unavailable because the geometry of spacetime itself has sorted the cosmos into what remains part of our possible future and what does not. There is no simple answer to that question. But perhaps the first honest response is this: it changes the mood of belonging. Many of us grow up with an unspoken feeling that the universe is, in some broad poetic sense, ours to explore. Maybe not by us personally, maybe not soon, but eventually. It feels open-ended. Galaxies are distant countries in a map that extends beyond the horizon. The assumption hiding underneath is that reality forms one navigable whole, and that limits are temporary. Technology will improve. Knowledge will deepen. The boundaries will recede. Cosmology interrupts that dream very gently, but very completely. It says some boundaries are not temporary. Some horizons are not invitations. Some roads are not waiting for better vehicles. The universe is not merely a field of destinations. It is a field already divided by causal isolation. And that can sound bleak at first, until we realize it is also telling us something true about our place. We are not the center of a map waiting to be filled in. We are participants in a local island of spacetime, aware of a much larger reality that only partly remains in conversation with us. That awareness carries a certain loneliness, but perhaps also a certain dignity. Because to know the limit is different from merely living inside it unconsciously. Let us make the feeling more concrete. Imagine standing on a shoreline at night, looking across a black sea toward thousands of tiny lights. From a distance, they all seem part of the same world. You could almost imagine villages there, ports there, lives unfolding there. The lights are visible. That visibility itself creates a sense of shared belonging. The sea is broad, yes, but it still feels like one sea under one sky. Then imagine learning that most of those lights are no longer reachable by any boat that could ever be built. Not because the ocean is stormy. Not because your ship is weak. But because the water itself is widening while you watch. The lights remain. The routes do not. That would change the meaning of the view. The beauty would remain. But the beauty would now carry a separation inside it. That is what the universe begins to feel like once expansion, dark energy, horizons, and lost futures all come together in the same understanding. You still look outward with wonder. But the wonder now has edges. This is why the loneliness of the expanding universe is not just about the future. It exists in the present as a condition of understanding. The moment we realize that most galaxies we can observe are already beyond any possible future contact, the sky changes character. It becomes less like a neighborhood and more like a memory field. Less like an open world and more like a vast arrangement of visible exiles. And that can provoke a very human discomfort. Because we do not merely want things to exist. We want the possibility of relation. We want the possibility that what is out there could, in some imaginable future, become part of our world. Even if we never go, we want the road to remain. We want openness, even abstract openness. The expanding universe denies that wish on the largest scales. And in doing so, it forces a more mature kind of awe. An awe not built on possession, but on witness. That may be the quiet philosophical shift at the center of this whole story. Perhaps the universe is not given to us as territory. Perhaps it is given to us, at least in part, as revelation. Something to behold, understand, and cherish, even when it cannot be joined. There is a humility in that. And maybe humility is one of the hidden gifts of cosmology. Because if the universe were fully accessible, perhaps we would imagine it too much in human terms. A place to conquer. A frontier to absorb. A larger extension of our own ambitions. But the unreachable cosmos resists that instinct. It reminds us that reality exceeds our projects. That existence is not arranged for our convenience. That the stars are not resources merely because we can name them. Some of them are there to teach us scale. Some are there to teach us limits. Some are there to teach us that beauty does not depend on availability. Still, the loneliness remains. And it is worth saying clearly that this loneliness is not irrational or sentimental. It emerges naturally from a certain collision between human consciousness and cosmic fact. We are creatures capable of imagining far more than we can touch, capable of inferring whole structures beyond our practical reach, capable of caring about realities with which we will never interact. We are not built merely to occupy our local environment. We are built to wander outward. So when science tells us that most of the outward reality is permanently closed to future participation, it touches something deep in us. It creates a kind of existential asymmetry. The mind can go farther than the future can. That is an unusual condition, and in some ways, a lonely one. The imagination can stand before 2 trillion galaxies. The accessible universe cannot. Perhaps that is why astronomy is so often accompanied by feelings that are not purely scientific. Wonder, yes, but also melancholy, tenderness, a sense of the sublime that includes not only greatness, but distance and irretrievability. These emotions are not flaws in our understanding. They are part of what it feels like when knowledge reaches beyond comfort. To know the cosmos properly is not only to know its scale, it is also to know its indifference to our instinct for nearness. Yet there is another side to this, and it matters just as much. Because if we stop at loneliness alone, we miss the most important response available to us. The unreachable universe does not only isolate us, it also reveals us to ourselves. It tells us what kind of beings we are that we can understand any of this at all. Think about what has happened here. On a small rocky planet orbiting an ordinary star in one galaxy among trillions, a species emerged that learned to measure redshift, infer the expansion of spacetime, discover dark energy, and reason its way toward the conclusion that most of the visible universe is already beyond future contact. That is an extraordinary fact, not because it makes us central, but because it makes us capable. Capable of receiving a truth larger than our instincts. Capable of living inside a local island while understanding the ocean beyond it. Capable of enduring the loneliness of scale without collapsing into meaninglessness. This may be why cosmology, when held carefully, does not actually leave us in despair. It leaves us in proportion. We are small, yes, but we are not trivial. A trivial species would never know the horizon was there. A trivial consciousness would mistake its island for the whole world. We do not. We know, at least in outline, how much lies beyond us. And knowledge of that sort is itself a kind of belonging. Not the belonging of control. The belonging of participation in truth. That may sound abstract, so let us put it more simply. We may never touch most of the universe, but we are still part of the universe becoming aware of itself. That is not a cure for loneliness, exactly, but it is an answer to it. Because loneliness begins to change when you realize that awareness itself is a form of relation, not full relation, not causal reciprocity across the cosmic horizon, but relation nonetheless. Ancient light reaches us. We read it. We understand something real about its source. The universe is not wholly mute to us. It withholds the future of distant places, but it still grants us their past. It still leaves evidence. It still allows us a certain intimacy with what we cannot possess. And perhaps there is something very beautiful in that arrangement. A severe beauty, yes, but beauty all the same. It asks us to love without owning, to wonder without expecting arrival, to see without demanding touch. Those are difficult lessons in ordinary life, and perhaps they are difficult in cosmology for the same reason. We are used to valuing what can be held, visited, entered, exchanged with. The universe suggests another category of value. Things can matter even when they remain forever beyond us. They can enlarge the mind, soften the ego, and deepen our sense of reality simply by existing and by being knowable in part. That, in part, matters. Because the loneliness of the expanding universe is not total. Our local group remains. The Milky Way, Andromeda, and our other neighboring galaxies are still part of one gravitational family. That family is modest by cosmic standards, but it is not nothing. It means the future does not reduce to absolute emptiness. There is still a lasting island. still a local structure with a shared fate. The wider cosmos recedes, but the nearby archipelago remains bound together for ages beyond human imagination. That is an important counterweight. The universe is not taking all company from us. It is narrowing the larger field while preserving a local home. And perhaps that too has a philosophical echo. Human life is always lived locally. We can imagine the globe, but we inhabit neighborhoods. We can contemplate history, but we move through days. We can think cosmically, but we love particularly. The local group, in a strange way, is the cosmic version of that truth. Our actual future belongs to a smaller community than the full visible universe suggests. That is not merely a loss. It is also a definition. It tells us where our lasting island is. And maybe part of wisdom, whether human or cosmic, is learning to honor both facts at once. The grandeur of the unreachable whole, and the intimacy of the reachable near. Still, the philosophical weight of the larger loss remains, especially when we think about time. Because the expanding universe does not simply tell us that most of reality is inaccessible now. It tells us that access itself is historical. That there are eras of greater openness and eras of greater isolation. That cosmic belonging changes with time. We happen to live during a chapter when the wider universe is still visible, still measurable, still legible on the grand scale. This means our loneliness is mixed with privilege. We are isolated, but informed. Future civilizations may be isolated and less informed. That is a profound difference. It means we occupy a rare window in which the cosmos still reveals enough of itself for us to understand the nature of our own eventual isolation. We are, in a sense, early enough to know what later ages may only dimly suspect. And that gives our moment a tenderness that is easy to overlook. We are not just living in the universe. We are living during one of the last eras when the universe still explains its larger structure so openly. That does not erase the loneliness, but it transforms it. Because loneliness becomes easier to bear when it is joined to witness. When it is not merely a lack, but a calling to pay attention. The night sky becomes not only a reminder of separation, but a temporary gift of evidence. A record still readable. A library still illuminated. If these quiet reflections help you settle into sleep, you can gently leave a like, subscribe, or share where you're listening from tonight. I always enjoy imagining these thoughts arriving softly in different corners of the world, while above all of us the wider universe continues its quiet retreat beyond reach. And perhaps that is the final turn of this part. The strange loneliness of an expanding universe is real. But it is not the last word. Because loneliness often makes us ask the wrong question at first. It makes us ask, why can't more of reality belong to us? But the better question may be, what does it mean that any of it does? What does it mean that we can see as much as we can, understand as much as we do, and live at a moment when the sky still carries so much of the story? The answer to that question leads us into the final part. Because once we have felt the loneliness, and once we have seen the horizon, the old light, the inaccessible futures, and the quiet narrowing of the cosmos, one final realization remains. We have to gather it all together. We have to ask, on the deepest scale, what is the true size of what has already been lost? Not just in numbers, but in meaning, in the shape of the universe, in the rarity of the moment we are living through now. And when we do, the whole story changes one last time. Part 10, The True Scale of What Is Already Lost. There is a moment, in any long journey through an idea, when the facts stop arriving one by one and begin to gather into a single feeling. Up to now, we have moved carefully. We have taken the story apart piece by piece. We began with the simple and unsettling claim that some regions of the universe are already beyond our reach. We learned that seeing is not the same as reaching. We learned that distance is not a fixed thing on cosmic scales, because space itself stretches. We stood at the edge of the cosmic horizon and felt the strange quiet of a boundary that marks not just what can be seen, but what can still be part of the future. We looked at the staggering numbers. We watched light itself fail to save the connection. We imagined future civilizations living under a lonelier sky, with fewer clues about the larger reality beyond their local island. And now, at the end, all of those threads begin to pull together. Because the true scale of what is already lost is not only a matter of distance. It is not only a matter of how many galaxies have slipped beyond reach. It is not only the number of stars, or clusters, or light years placed forever outside the future of any journey we could begin today. It is also the scale of what those losses mean. The scale of the silence. The scale of the separation. The scale of the strange privilege of being alive at a time when we can still see so much of what is leaving. That is the final shape of this story. And perhaps the easiest way to feel it is to stop thinking, for a moment, about measurements and start thinking about the sky itself. Not a telescope image. Not a graph. Just the sky. Imagine lying awake at night, or perhaps on the edge of sleep, under a dark stretch of stars. To the eye, it looks stable, peaceful, ancient. It does not advertise its motion. It does not confess how much change is hidden inside its calmness. The stars hang there as though the universe were one great still room, as though its contents had simply been arranged a long time ago and left in place. But now you know something else. You know that the stillness is not stillness. You know that the great dark between galaxies is expanding. You know that while we sit under the sky, the architecture of possible futures is changing. Not violently. Not with any visible drama. But truly. Quietly, continuously, and somewhere out there, beyond the horizon of future contact, galaxy after galaxy continues existing without any remaining bridge back to us. Their old light may still drift in, their present does not. That is already enough to make the universe feel different. But the true scale of what is lost becomes even deeper when we remember that galaxies are not points. A galaxy is not a dot on a chart. A galaxy is an enormous internal world. Hundreds of billions of stars, sometimes more. Around those stars, perhaps planets beyond counting. Dark matter halos larger than the visible galaxy itself. Clouds of gas. Ancient globular clusters. Stellar nurseries. Supernova remnants. Black holes swallowing matter in silence. Entire histories of structure, collision, birth, and decay playing out across spans of time so large that even civilizations, if they exist there, might rise and fall many times over without the galaxy itself doing anything more dramatic than slowly turning. When one galaxy slips beyond reach, what is lost is not one object. It is one universe-sized story in miniature. And when most galaxies in the observable universe have already slipped beyond reach, the loss is not merely numerical. It is narrative. It is the loss of future access to uncountable local dramas, local skies, local arrangements of matter and time, each one with its own possible past and possible unfolding present. This is why the scale resists feeling real. The mind can repeat the number, but the reality inside the number keeps overflowing it. 2 trillion galaxies, perhaps. Roughly 94% already beyond future reach. Only a small fraction still part of the reachable cosmic conversation. These are not just quantities. They are statements about the structure of existence. And yet even now, the universe remains kind enough to let us see some of what we can no longer join. There is something almost paradoxical in that. If the broader cosmos had simply vanished from view the moment it slipped beyond reach, perhaps the truth would be easier to understand. The sky would go dark, and the message would be clear. But the universe does not work that way. It lets the past remain visible after the future has closed. It lets ancient photons continue their long arrival. It lets us look outward into a realm that feels open long after much of it has become causally sealed. This creates the peculiar emotional condition we have been circling all along. The lost universe is still luminous. That may be the most haunting sentence in the entire story. Not because it is sad in a theatrical way, but because it is so calm. The lost universe is still luminous. Its old light still reaches us. Its present cannot. So what, then, is the true scale of what is already lost? It is the scale of a visible abundance that is no longer matched by future access. It is the scale of a cosmos still generous with memory, but increasingly strict about participation. It is the scale of nearly everything we can see becoming, in one sense, archival. If you wanted to picture it another way, you might imagine the observable universe not as open territory, but as a great library at twilight. The shelves are still full. The volumes are still there, glowing faintly in the dimness. We can still read vast parts of the collection, but most of the doors that once connected that library to the living world beyond it have already been closed. New pages can no longer be exchanged with most of those distant shelves. What remains to us is not empty. It is immense. But it is immense in the way a preserved record is immense. There is a tenderness in that idea. And perhaps that tenderness is one reason this subject belongs so naturally in the late hours, when the mind is loosening from the ordinary scale of the day. In daylight, we live among tasks, rooms, messages, and immediate concerns. At night, especially in those quieter moments before sleep, we are sometimes able to feel the larger architecture around us. We can sense how small our lives are, but also how deeply they sit inside something vast enough to hold both beauty and impossibility in the same gesture. The expanding universe is exactly that kind of gesture. It offers revelation and limitation together. It shows us more than we can ever touch. It lets us know what we cannot keep. And perhaps this is where the story becomes most human. Because the universe is not the only thing in life that teaches this lesson. There are many things we can see and understand without ever being able to return to them, possess them, or continue them into the future. Childhood is like that. Certain places are like that. Old friendships. Past versions of ourselves. A song heard at the right moment. A house once lived in. A season of life whose light still reaches us, even when the present can no longer go back and rejoin it. In that way, the cosmos feels strangely familiar. Not because it is small enough to resemble us, but because our lives contain quieter echoes of the same structure. Old light, closed roads, visible memory, a future that narrows while the evidence of what has been remains luminous for a while. Perhaps that is why this science can feel less like cold abstraction and more like something almost intimate. It describes the sky, yes, but it also describes something about the logic of existence itself. That not everything real remains available. That visibility does not guarantee future contact. That some beauty is deepest precisely because it is temporary, and because we know we are seeing it during one of the last moments when it can still be seen in this way. That thought brings us to one of the most important truths in the whole story. The true scale of what is already lost also tells us the true rarity of now. We do not live at just any random point in cosmic time. We live in a very particular era. An era late enough that stars, planets, and galaxies have had time to form. Late enough that chemistry, life, and consciousness can emerge. Late enough that the universe has become legible in structure. But not yet so late that the great evidence of its wider reality has fully faded from view. That combination is astonishing. We are here while the cosmic background can still be measured. We are here while other galaxies are still visible in overwhelming numbers. We are here while the expansion of the universe can still be inferred from the sky itself. We are here while the larger story remains written across the darkness in a language our instruments can still read. Future civilizations may not inherit such a clear sky. The wider universe may continue existing, but much of its evidence will have retreated into faintness, silence, or horizons that no longer give themselves away so generously. The cosmos may become harder to interpret. The map may appear smaller than it truly is. The library may remain, but more of its shelves will be dark. That means our moment is not ordinary. It is a window. A brief and privileged one, on cosmic terms. And that, perhaps, is the most moving answer to the question of scale. The true scale of what is already lost is so immense that it makes the surviving visibility of the present feel miraculous. We are standing inside an era of temporary clarity. That does not mean the universe is arranged for us. It means we are lucky enough to exist during one of its more revealing chapters. A small, thinking species on one planet has found itself awake at a time when the sky still contains the evidence of a far grander whole. We can still see enough of the wider universe to know that most of it is already beyond us. That is an extraordinary kind of awareness. Painful, perhaps, in a gentle way, but extraordinary. And maybe this is why the story should not end in sadness alone. Yes, there is loss here. Yes, there is a strange loneliness in knowing that most of the visible universe will never be ours to reach, and that so many galaxies are already gone from the future in every practical and even ideal sense. But there is also a kind of gratitude hidden inside that realization. Because to know the loss is already to have received something immense. We have received the evidence. We have received the old light. We have received the chance to understand the architecture of the horizon while the horizon still leaves enough of itself visible to be known. That is not ownership. It is witness. And witness, when the thing witnessed is this vast, is its own form of privilege. Perhaps the universe is not asking us to conquer it. Perhaps it is asking us to notice it. To notice how extraordinary it is that existence can grow beings capable of learning what redshift means, what dark energy does, what a cosmic event horizon is, what it means for light itself to fail to preserve connection, and what it means to live in a time before the wider sky goes quiet. There is something deeply peaceful in that thought. We do not need to own the universe for it to matter. We do not need to reach every shore for the sea to be beautiful. We do not need the road to remain open forever for the view to be worth beholding. Sometimes the value of a thing is not that it can be kept, but that it can be seen while it lasts. And the larger cosmos, in all its unreachable breadth, may be exactly that kind of thing. A vast, temporary revelation. A brightness passing through our era. A field of ancient messages arriving just in time for beings like us to understand what they mean. If you gather everything we have followed tonight, the horizon, the old light, the expanding distance, the fading future, the loneliness, the privilege, and the silence, perhaps the final truth sounds something like this. Most of the universe we can see is already gone from our future. And yet we are alive in the rare age when its light still reaches us. That is the true scale of what is already lost. Not only that the loss is immense, but that the surviving view is precious. Not only that the cosmos is retreating, but that we still stand here, just early enough, under one of the last broadly readable skies. And perhaps that should change the way we look up. Not with despair, not even mainly with grief, but with a slower kind of reverence. The stars above us, the galaxies beyond them, the redshifted structures stretched across billions of light years, these are not merely distant decorations. They are part of a temporary conversation between our local island and a much wider reality that will not always remain so available. We are hearing the larger universe while it is still speaking clearly enough to be heard. One day, far beyond any human lifetime, the sky will grow quieter. More of the galaxies will fade. More of the evidence will slip into wavelengths too long, too faint, too remote. Future minds may live under a darkness that does not betray how full the universe once seemed. But not yet. Not for us. For us, the great lights are still here. The old messages still arrive. The library is still illuminated. And so perhaps the most fitting way to end is not with a conclusion in the ordinary sense, but with a kind of invitation to stillness. To imagine, just for a moment, the Milky Way turning slowly above a sleeping Earth. To imagine Andromeda moving toward us across millions of years. To imagine all the unreachable galaxies beyond, still real, still unfolding, still sending us the last bright traces of a more connected cosmos. To imagine that almost all of them are already beyond any future ship, any future message, any future arrival. And then, beneath all of that, to feel something quiet and almost grateful. That we are here. That we can know this. That the universe, for all its distance and silence, has still left us enough light to understand the shape of what is leaving. If these quiet journeys through science and the cosmos help you rest, you can gently leave a like, subscribe, or share where you're listening from tonight. I always enjoy imagining these thoughts drifting softly into different rooms around the world, while above us all the night sky keeps offering its ancient, patient light. And now, perhaps, it is enough simply to let that light remain what it is. Not a promise of possession, not a map of places we will one day own, but a final, beautiful reminder that reality is larger than access, larger than reach, and still, somehow, kind enough to be seen before sleep.